is to promote the conservation of ocean crabs through exhibition car. Let's have a beautiful encounter with ocean crab.
Hi everyone, we are Team Green Future.
The purpose of our action is to transform a marine waste styrofoam and regenerate it into seawater air-filled battery.
We are Team Green Future, here to protect the ocean.
Hello everyone,
We are See the Utopia Sea.
let's watch our showcase video.
Hello, we are Indigo Waters. Our proposal is to use microaerometer to establish a model to predict the accumulation events of marine debris. When the model is ready, we will share it to beach authorities and communities near the coastline so they can monitor the beach on their own and they can plan how to do the beach cleanup efficiently.
Hello everyone, we are Prince Wong and his happy friend. And this time our hope is to promote the local culture of Longgang by combining the one-year festival with a marine clean-out activity. Here is the Prince Wong. The ocean will be clean from now on. Thank you.
Hello everyone, we are the Asia Alliance. We are the team to use the marine innovative technology to solve the marine debris issue. This year, we are honored to bring our proposal. We built the UAV Asia Fighter to cooperate with the beetle community to prevent the marine debris into the ocean. We are happy to invite everyone to join us. Fight for Asia Ocean!
Hello everyone, we are entry team from National Taiwan University. Today, we are going to share our invention which can obtain resources from the ocean without damaging the marine system. And we are expecting to the success and for use in the future. Go, go, magic, go!
Hello, we are RC. A group of 4 students in grade 10 have been working on this project for many months.
We believe that small actions, like the ones we promote on our app, can make the biggest difference. If we take them together, we can surely save our seas.
When you're faced with a problem, how do you approach the problem and how do you solve it?
Many people might choose to create solutions combating the problem.
However, we decided to take an alternative route. We will eliminate the problem.
Our solution is a tracker that can be attached and detached to fishing gear, which works on the basis of global positioning, system, and web technology.
This allows the location of the ghost gear to always be monitored and no one preventing any loss for purposely abandoned gear.
Thank you for listening.
Hello, this is TSJB. We are a group of 4 students from Northbridge International School of Cambodia.
And we are addressing mercury pollution, where in our proposal we have designed an unmanned underwater vehicle that can detect mercury in the water.
Thank you for watching.
It is really a pleasure and a privilege for us to join in our Ocean Child contest.
Because we love the ocean. Salam sejahtera Taiwan 2023台湾海洋国际青年论坛，我们来了。We are Guardians of the Galaxy from University Malaysia Krika. Sea turtle survival are vital indications to our ocean's health and ecosystem. Their declining population is due to various threats such as habitat loss, pollution, and bycatch. To tackle this issue, we have developed a solution that uses microwave techniques to improve the conservation work for sea turtles. Thank you.
Hi, Ocean Challenge. It's our honor to be here. I'm Yulia from Carbon. Our aim is to build a blue forest for decarbonization and protect the local society from erosion and tsunami by coupling the solution with aquaculture. We want to expand our coverage by further doing nature-based solutions for a more thriving blue society. Thank you.
Hi, we're the plastic chasers. Let's make our oceans pure again.
We are the Aqua Guardians.
A group of high school students from Kansha International School.
With Aqua Guardian, we hope to increase the coverage of water quality monitoring in Taiwan.
Reduce its cost and obtain a more comprehensive data source.
Aqua Guardians, assemble! Let's go! Ocean needs help. We started young. Let's break it down now. Hi, we are.刚刚好像有什么东西滑进去了。Let's save the ocean. Hello everyone, we are the Ocean Detector. Protect the ocean for today and tomorrow. We are eager to participate in this project to bring impacts to further generations. Thank you everyone. Hi everyone, we're Timothy and we're from Kansha International School. Our project is called Sea4Can. To conserve our ocean sustainability, we decided to recycle plastic waste and turn them into board games for students and educators. Let's see the fortune!
Hi, we are AC. So we are from International Bilingual School at Taiwan Chinatown. Our proposal is about using probiotics in aquaculture to stop eutrophication and ocean pollution.
Hopefully we can enact those and make it a better environment.
Hello everyone, we are the International Roots and Shoots team from Zhangjiang Christian University. Our project proposal is Marine Conservation Currents and Visual Currents, NFT, Non-Fungible Token Initiative. We will promote the international marine conservation through environmental education as the final part of our project. Yes, together we can make a difference. Follow your passion.
Hi everyone, we are from the National Taipei University of Technology.
And we are the team Environmental Protection with this West.
Our topic is irreversible fish nets.
Let's keep marine life a clean home together.
We are Yang Yang Mao from National Taipei University of Technology. We promote cat food. There are environmental friendly, healthy, and fun. Protect our ocean, protect our cat future. Hello everyone, we are Xie Ho. We are from Visual Communication Design of the STUST. Our thing is to promote the conservation.
All right, everyone. Some of our guests are still on their way, so we'll begin in about 10 minutes. But before we begin, please make sure that you have silenced your phone. Thank you very much. 那提醒各位贵宾，不好意思哦，我们有些贵宾还在路上，所以我们会再过10分钟之后，呢才会正式开始哦。那请大家就座，也提醒大家将手机转为震动或静音，谢谢。
Soup is featured card. Let's have a beautiful encounter with horseshoe crab. Hi everyone, we are Team Green Future.
The purpose of our action is to transform a marine waste in styrofoam and regenerate it into seawater air-filled battery.
We are Team Green Future, here to protect the ocean.
Hello everyone, we are See the Utopia Sea. Let's watch our showcase video.
Hello, we are Indigo Waters. Our proposal is to use microaerometer to establish a model to predict the accumulation events of marine debris. When the model is ready, we will share it to beach authorities and communities near the coastline so they can monitor the beach on their own and they can plan how to do the beach cleanup efficiently.
Hello everyone, we are Prince Wong and his happy friend, and this time our goal is to promote the local culture of Longgang by combining the one-year festival with marine cleanup activity. Here is the Prince Wong. The ocean will be clean from now on. Thank you.
Hello everyone, we are the Asia Alliance. We are the team to use the marine innovative technology to solve the marine debris issue. This year, we are honored to bring our proposal. We built the UAV Asia Fighter to cooperate with the beetle community to prevent the marine debris into the ocean. We are happy to invite everyone to join us. Bye bye, Asia Ocean!
Hello everyone, we are Today, we are going to share our invention, which can obtain resources from the ocean without damaging the marine system. And we are expecting to the success and for use in the future. Go, go, magic, go!
Hello, we are RC, a group of 4 students in grade 10 that have been working on this project for many months.
We believe that small actions, like the ones we promote on our app, can make the biggest difference. If we take them together, we can surely save our seas.
When you're faced with a problem, how do you approach the problem and how do you solve it?
Many people might choose to create solutions combating the problem.
However, we decided to take an alternative route. We will eliminate the problem.
Our solution is a tracker that can be attached and detached to fishing gear, which works on the basis of global positioning, system, and web technology.
This allows the location of the ghost gear to always be monitored and known, preventing any loss for purposely abandoned gear.
Thank you for listening.
Hello, this is TSJB. We are a group of 4 students from Northbridge International School of Cambodia.
And we are addressing mercury pollution, where in our proposal we have designed an unmanned underwater vehicle that can detect mercury in the water.
Thank you for watching.
It is really a pleasure and a privilege for us to join in our Ocean Child contest.
Salam sejahtera Taiwan 2023台湾海洋国际青年论坛，我们来了。We are Guardians of the Galaxy from University Malaysia Trika. Sea turtle survival are vital indications to our oceans, health, and ecosystem. Their declining population is due to various threats such as habitat loss, pollution, and bycatch. To tackle this issue, we have developed a solution that uses microwave sensors to improve the conservation work for sea turtles. Thank you.
Hi, Ocean Challenge. It's our honor to be here. I'm Yulia from Carbon. Our aim is to build a blue forest for decarbonization and protecting the local society from erosion and tsunami by coupling the solution with aquaculture. We want to expand our coverage by further doing nature-based solutions for a more thriving blue society. Thank you.
Hi, we're the plastic chasers. Let's make our oceans pure again.
We are the Aqua Guardians.
A group of high school students from Kamcha International School.
With Aqua Guardian, we hope to increase the coverage of water quality monitoring in Taiwan.
Reduce its cost and obtain a more comprehensive data set.
Aqua Guardians.
Distinguished guests, our very good friends and international teams who join us online. Ladies and gentlemen, good morning. 各位现场以及线上的贵宾、好朋友以及所有的同学们，大家早安，大家好。怎么有点小声？再一次好了，大家早安，大家好。Yeah, that's more like it. Okay, ladies and gentlemen, welcome to 2023 Ocean Challenge hosted by the Ocean Affairs Council and the American Institute in Taiwan. AIT 高雄 Branch Office 非常欢迎大家呢参加由海洋委员会以及美国在台协会高雄分处所共同主办的2023台湾海洋国际青年论坛。What we want to do is to bring more young people, yes, like you all here, together to empower them, to share with us more innovative ideas, and to join us in addressing addressing some of the most pressing issues facing our ocean. Together, we can make marine sustainability possible. 没错。那我们这一次呢，真的要非常谢谢有这么多来自于国内外的这个团队，我们的同学、青年学子们参加我们的提案哦，一起加入我们的行列，要来守护海洋，促进海洋永续发展。And of course, Ocean Challenge is not possible without the great support and participation of a lot of our good friends and partners. So let me begin by introducing some of our VIP guests with us today. If you hear names, would you please stand up and say hi to us? 那我们首先呢，为各位介绍莅临今天现场的长官以及贵宾。Yes, of course, we have Ms. Sandra Oker, Director of American Institute in Taiwan. 美国在台协会孙小雅处长，欢迎。接下来为各位欢迎海洋委员会管碧玲主任委员。Leading Guan, the Minister of Ocean Affairs Council， 非常欢迎。那同时呢，我们也要欢迎海洋委员会洪文玲副主委，文玲洪 Deputy Minister of Ocean Affairs Council。那我们也要非常欢迎哦，今天赖瑞龙立法委员呢是由团队的林公正执行长代表出席。We have 公正林 here on behalf of Legislator Ray Long Lai, thank you so much for joining us today. And next, I would like to welcome Thomas Wang, Branch Chief of American Institute in Taiwan, 高雄 Branch Office 美国在台协会高雄分处黄东伟副处长，欢迎。那我们所在的这个场地呢，今天非常谢谢国立科学工艺博物馆李秀凤馆长 ，We have 秀凤李 Director General of National Science and Technology Museum。非常欢迎。那接下来呢，为各位介绍海洋委员会刘国烈主任秘书郭烈刘 Chief Secretary of Ocean Affairs Council， 海洋委员会海洋保育署黄向文署长向文黄 Director General Ocean Conservation Administration Ocean Affairs Council， 国家海洋研究院陈建宏院长，让我们掌声欢迎院长建宏陈 President of National Academy of Marine Research。也要非常谢谢外交部南部办事处的刘长成副处长，今天特别出席长成刘 Deputy Director of Southern Taiwan Office Ministry of Foreign Affairs， 以及外交部云嘉南办事处的林文俊主任兼副处长，也一同出席温俊林 Deputy Director of 云林嘉义台南 Office Ministry of Foreign Affairs。 Welcome， 非常欢迎哦。Okay, thank you once again for joining us for Ocean Challenge 2023. And now to welcome you all, ladies and gentlemen, please join me first in welcoming Ms. Sandra Oker to the stage to give us the opening remark. Please welcome Director of AIT, Ms. Sandra Oker. 接下来我们首先有请美国在台协会孙小雅处长上台致欢迎词。
Minister Guan, Deputy Minister Hong, distinguished guests, student participants, good morning. 早安。
早。
I am very pleased to be here today in person at the launch of the 5th Ocean Challenge event, a joint event between the American Institute in Taiwan and the Ocean Affairs Council. I am particularly excited to be here this year to mark the return to an in-person format after 2 years of virtual ocean challenges due to pandemic restrictions. It is an absolute pleasure to be able to see so many promising young faces in the audience today. Since I first lived here in the 90s, Taiwan has developed into an advanced economy and a vibrant democracy, and the U.S.-Taiwan partnership has steadily broadened and deepened. The United States and Taiwan share many values, including respect for rule of law, a commitment to free and fair trade, and support for civil liberties at home and around the world. Our shared values also include a shared desire to protect and preserve our planet for future generations by reducing harmful emissions and conserving our natural resources. Chief among those natural resources is our oceans, the protection of which is critical to ensuring a sustainable future. The climate crisis is an ocean crisis. We must combat greenhouse gas emissions and their impact, including ocean warming, sea level rise, and ocean acidification. These challenges are global in nature and thus require a global response. To make real progress, we need sustained, coordinated efforts from officials, experts, civil society, and private sector partners around the world. For all of this to happen, we need involvement from youth innovators like you here today. We need you to push your leaders to take action on ocean conservation. And we need you to become the next generation of experts, activists, and public or private sector leaders who will contribute creative solutions to these vexing challenges. That is why we are holding the Ocean Challenge. This event is designed to raise awareness among youth of the critical issues confronting our oceans and to inspire your engagement. By doing this, Ocean Challenge will allow us to leverage one of Taiwan's greatest resources, its talented and innovative youth. If we are going to protect our oceans, we need your creativity, your passion, and most importantly, your involvement. So I would like to thank OAC for their continued partnership and support for this important youth-focused endeavor. As a result of our close partnership, the Ocean Challenge event has grown and expanded every year. What started off as a regional high school event has now evolved into a robust competition of teams of high school and college students and young adults from across Taiwan, as well as international teams from countries all over the world. I look forward to continuing our collaboration with OAC to further develop this important initiative and to create new opportunities to advance our common goals on environmental protection. The United States will continue to work closely with Taiwan and our other partners around the world to advance ocean conservation and other global environmental issues. And I sincerely hope that all of you here today will join this effort and strive to make a positive contribution to the global community. Once again, I want to thank Minister Guan, Deputy Minister Hong, and the Ocean Affairs Council for their leadership on this issue and for their close cooperation and partnership with AIT. To the students participating in this year's competition, thank you for your enthusiasm and your willingness to get involved. I hope your participation in Ocean Challenge has sparked in you an even greater interest in the environment and in our collective stewardship of this planet. I encourage all of you to continue applying your creativity to solving some of the greatest challenges that confront mankind. Thank you. 谢谢大家。
谢谢 Thank you so much to Director Sandra Oker of American Institute in Taiwan. Thank you once again. Yes, this is a platform for us to learn from each other, for us to work with each other. Thank you again to Director Oker. 再次谢谢美国在台协会孙小雅处长哦。那接下来呢，我们要有请海洋委员会管碧玲主任委员上台致欢迎词，让我们掌声欢迎主委。Next, please welcome Biling Guan, Minister of Ocean Affairs Council, also to the stage to share with us the opening remark.
I think allow me to speak in Chinese, okay? 美国在台协会孙小雅处长、杭东伟分处长以及赖瑞荣委员办公室林执行长，我们洪副主委以及我们的李馆长，还有在座各位评审委员各位贵宾、参赛团队的各位伙伴，大家早安，大家好。
好，
今天很高兴能够在这里欢迎各位参加2023台湾海洋国际青年论坛。这是我们台美双方5年来5度携手合作办理此论坛。我和孙处长一样，对于受疫情影响之后能够实体开会感到十分高兴。然后我在这里也要特别说明，今年入选的24个参与决赛的团队，是我们从62组提案中脱颖而出，进入今天的决赛。来，我们一起为今年参赛的团队鼓掌鼓励一下。 今天他们带着海洋危机提案作品来与大家分享，在座的各位接下来可以拭目以待。这几天 NVIDIA 黄仁勋总裁的演讲很轰动，他鼓励大家要用跑的，不要用走的。在座的各位参赛者，您们为了解决问题，让您们的智慧跑在现实的面前很远，所以你们其实就是用跑的，而不是用走的一群年轻人了，对不对？哦，是吗？你们都用走的吗？在座的各位都走在现实问题的前面，要去解决问题。我认为你们就是用跑的，而不是用走的一群年轻人了。台湾海洋国际青年论坛提案活动旨在呼吁青年学子要正视海洋恶化的问题，鼓励他们采取行动，让参赛者以海洋科学的方法提出解决海洋问题的创新解决方案。回顾这5年来，已经吸引了22个国家、70间大专与高中职学校、602位有志的青年共同参与这个活动，激励了许多年轻的一代，让他们去正视海洋环境所面临的挑战，而且提出创意的解方。这个活动提供了一个交流的平台，让大家互相学习，分享彼此的观点与看法。我很高兴看到这个活动每年参与的人数都持续的扩大，和孙处长看到的一样，这个活动已经逐渐的变得越来越具备国际化的青年平台了。那么今年我们很荣幸也邀请到了美国国家海洋暨大气总署 NOAA Dimitri 科学家来为我们发表演讲，介绍 NOAA 如何运用科学工具搜集地球大气跟海洋环境数据，进而预测未来的海洋，让我们更加了解全球海洋环境的变化，进而协助分析如何保护我们的海洋。在此也特别谢谢在线上为我们参加这次活动的特别的参与。就在昨天，蔡英文总统公布了《海洋污染防治法》的修正案。这个法是一个大转型，它落实了充实财源、强化工具、公民参与跟国际接轨这4大目标，让台湾洁净海洋的梦想又往前迈向了一步。今天入选的决选的参赛队伍，你们都是我们可以积极期待的未来的海洋守护者。我看到你们每个团队都提出了一个科学核心的解决方案，期望能够扭转我们海洋所面临的各种问题。每个提案都充满了智慧的结晶，我很期待你们延续这个提案的发想，希望未来能够将它落实。因为光有法律的架构是不够的，必须要有各位持续的参与，才能够让法律它产生内在的力量，才能够确保海洋永续的发展。最后，我要特别感谢我们的合作伙伴 AIT 孙小雅处长的卓越领导，以及 AIT 高雄分处黄分处长的团队全力的支持，每个人都为了筹办这个活动尽心尽力。孙处长专程南下主持会议，我还要特别表达感谢。处长说的，您特别的鼓励我们在座的年轻人，就让我非常感动的，迫不及待的也想要告诉年轻人，年轻人这个符号在台湾的历史上是具有非常重大的意义的。台湾的历史是年轻人创造的，在台湾国家的历史是年轻人创造的。我举4个故事来呼应孙处长对大家的鼓励。年轻人真的很厉害。2013年7月15日到8月6日，才23天，年轻人站出来，他们呼应了、声援了洪仲丘事件，才用23天就推翻了我们的军事审判制度。更不用说追溯到1990年的3月学运，才7天就推动了我们国会的全面改选。而在2014年的3月18号到4月10号，也是23天， 台湾的年轻人再度站出来反服贸，保护了台湾的经济体制跟基本架构，而且还创造了一个政党，让台湾可以用现在的经济体制去迎接今天晚上将要签署的21世纪台美贸易协定。台湾的年轻人甚至于从2016年的12月开始，有25万人去参加一个音乐会，呼吁婚姻平权，推动了2年半而已，台湾就立法成为婚姻平权合法化的国家。年轻人这个符号在台湾的历史是改变世界的符号。今天我们可以改变我们的国家，可以改变我们的历史，要抢救我们的海洋，当然是指日可待。今天让我们就从这里开始来保护我们的海洋。最后我要预祝今天的论坛能够圆满顺利，也祝福大家有个收获满满的2天议程。谢谢大家。
掌声谢谢主委，主委是在台上稍微留意一下，等一下一起合照。Minister Guan would like to take this opportunity to share her gratitude to AIT for being such a reliable partner for 5 years. And for 5 years, we have seen more than 600 young people joining us from 20 countries and showing us their innovation and also creative ideas. Taiwan is a country of young people. Taiwan is a country for young people. It is young people here in Taiwan that push our democratic progress forward, that also make the same-sex marriage possible here in Taiwan. And Taiwan just passed the Marine Pollution Control Act, showing our determination once again to be a part and to take responsibility as a member of the international community to enhance marine and also ocean conservation. Thank you once again to Minister Guan. 那接下来呢，就是我们的合照时间了。All right. I'm having Minister Guan here on the stage to have some photos. So for that, I would like to welcome Director Sandra Oker from AIT once again to joining us on the stage. 我们是再次掌声有请美国三人协会孙小雅处长。We also like to welcome Thomas Wang, Branch Chief of AIT 高雄 Branch Office, 以及我们的主办单位美国在台协会高雄分处的黄登伟分处长，随时到台上来。Yes. And next, I'm going to have Minister Guan, Director Oker, and also Chief Huang to have photos with team representatives and teachers from the teen category, from the youth category, and also from the professional category. All right. 那接下来呢，我们要请台上的贵宾哦，分别和我们的青少年组、青年组以及社青组的团队代表以及我们的老师一起合照。Firstly, I'm going to bring the people from the teen category, team representatives and teachers. 首先请这个青少年组我们的团队代表以及老师，现在就可以拿着团队的队牌到舞台上来了，好不好 ？OK。I'm calling out people from the teen category. Please bring your signs and join our guests on the stage. Hurry, all right? We don't want to keep our guests on the stage waiting, all right? 我们大家动作快一点点哦，不要让台上的贵宾等候了。我们每一个团队有一个代表，加上我们的老师，带着我们的招牌，我们每一队的队牌一起到台上来 ，all right? Hey. 首先呢，我们邀请到的是我们的青少年组。Okay, please join our guests on the stage. 可以蹲在前面 ，OK， 没问题。Yeah, do we have all the people? Yes, the team representatives, teachers. All right. Okay. The first one. Yeah, you can take your mask off for the group photo. 好，首先第一张呢，先。大大的微笑 ，a big smile for the first photo. 3, 2, 1. And the second one, because it's all about young people, so they want us to be as lively as possible. So maybe we can do this or whatever. 一个爱心好吗 ？Yeah, whatever. Whatever good is good. Okay. Yes, that's perfect. Okay. Just channel your young person. Oh, okay. All right. Thank you so much, and Minister Guan and also Director Oker and Chief Wang, we want you to remain on the stage, and people from the team category, you may return to your seats. Thank you so much. All right. 那我们刚才来到现场的呢是许志杰立法委员 ，Just joining us, we have legislator 志杰旭 ，Please welcome him. 立委先加入我们的合照 ，OK？ 我们刚才呢已经跟青少年组合完照了，那接下来我们要邀请青年组，我们请青年组的团队代表以及青年组的老师。好，我们现在就到台上来哦。Next, we'd like to welcome the team representatives and teachers from the youth category. Yes, please join us on the stage. OK， 我们青年组的团队请到台上来。我们这次呢一样有这个6组的团队哦入围。我们最后的决选 ，we have 6 teams making it to the final from the youth category. All right. 好，首先呢，这个好，我们同学赶快到台上来哦。All right. 我们同样呢有来自于这个南台科技大学的这个团队的代表。好 ，OK， 第一张，好，还有一位同学，好，加紧脚步 ，All right。第一张一样，先微笑 ，a big smile, everybody. And the second one, be creative. 第二张 ，yeah, okay, that's good, all right. 第二张 ，3, 2, 1. Thank you so much， 谢谢。我们团队的代表跟老师可以先回座了。我们请主委呢，我们再留步一下。我们还有一张照片呢，要跟这个社青组的这个代表一起来合照。And we have one last photo on the stage. Okay, we are going to bring out the team representatives and teachers from the professional category. 有请社青组团队代表。如果我们指导老师也有在现场的话呢？也请到台上来一起合照 ，OK？ Please join us on the stage, everybody. All right. Okay, please look at the camera in front of you. All right. 3, 2, 1. 好，这个社青组大家年纪比较大一点，但没关系，还是可以非常的有活力。All right. Okay. The second one. Okay. Do whatever poses that you like. Okay, 3, 2, 1. Okay, once again, put your hands together for Minister Guan, for Director Oker, for Chief Wan. On the stage, thank you so much. Please return to your seats. Actually, we want you to return to your seat and take one last photo, all right? 我们请这个主委处长。我们回到座位上，我们再请摄影师到舞台上，我们拍开幕式的最后一张照片。We have one more photo left to be done for the opening ceremony. OK？ 好，我们请这个贵宾呢回到您的位置上。我们请摄影师在舞台上帮今天参加我们2023台湾海洋国际青年论坛的所有的贵宾朋友们拍一张照片哦。All right, everybody, please look at the camera in front. On the stage, firstly in front of you, 先看中间 and then to your left, 看向左边 and then to your right, 看向右边然后再回到中间，我们后面是有动态摄影，对不对 ？Yeah, and we are also filming a video. Yeah, everybody, 可以稍微拖一下没关系 Yes, okay. Yeah, and one last one. 最后还有一张 and it will be a bit more complicated for this one. Firstly, hold out your left hand. Let's do an O with your left hand. 左手弄成一个 O, 我们 Ocean Challenge. 所以我们左手弄一个 O, and with your right hand, let's do a C. Yes, Ocean and Challenge. Okay, left hand O, and right hand C, and then here comes the complicated part. Please cross your arms. 然后呢，再交叉，没错，再交叉。OK，交叉之后，我们3、2、1，大家一起说 Ocean Challenge， 好不好 ？By the count of 3, that everybody say Ocean Challenge. You ready? 3, 2, 1. Ocean Challenge. Give yourself a big round of applause. Woo! All right, that's it for the opening ceremony of Ocean Challenge 2023. We'd like to thank Director Sandra Oker and Minister Guan once again for your participation. Thank you so much. 那我们开幕仪式呢就到这边圆满结束。我们要非常谢谢乡下处长管碧玲主委以及我们贵宾到现场。我们是不是再次给处长跟主委一个最大的掌声？谢谢。Thank you so much！ 再次谢谢我们贵宾的莅临哦，没错，就像是处长以及主委刚才所提到的，我们这个已经举办5年了，每一年的这个台湾海洋国际青年论坛呢，都可以看到有很多国内外的团队青年学子们呢，拿出他们最具有创意的提案以及想法。Yes, for 5 years, we really are impressed.And also sometimes very surprised by the very innovative and creative ideas proposed by our young people, not just here from Taiwan, but also from other countries in the world. Yeah, just like Minister Guan just said, we have more than 600 people from 20 countries joining us for the Ocean Challenge for 5 years in a row, all right? And before we move on to the presentations, we have a keynote speech for everybody.那在我们进入到各组的成果发表之前呢，我们首先安排了一场专题演讲，就是主委刚才为我们所提到的，我们为大家邀请到的是美国的 NOAA 美国海洋大气总署的专家，来跟我们分享的主题呢是海洋建模以及预测，透过模型是否真的可以预测未来呢 ？Ladies and gentlemen, next we are going to hear a talk from Dr. Dmitry Dukovsky, physical scientist of National Oceanic and Atmospheric Administration, USA. And we're very sorry that he couldn't be here with us today, but he has a pre-recorded video for everybody. 他今天虽然说没办法来到现场，但是他已经预录了一段影片，要请各位贵宾一同来观赏。Let's have a look. 请看。
Hello, everybody. I would like to thank the organizing committee for inviting me to speak at the Ocean Challenge 2023. I'm honored to be here. My name is Dmitry Dukovsky. I'm a physical scientist. I work at the Environmental Modeling Center of the National Weather Service at National Oceanic Atmospheric Administration. The center is located in College Park, Maryland, United States. In my work, I use numerical models to predict the ocean and sea ice conditions and to study physical process in the ocean and sea ice. My presentation today focuses on numerical models used for ocean and sea ice predictions, model predictability, and applications of ocean and sea ice forecasts. I will start by reviewing what prediction is and what type of prediction models exist. Then we'll talk about how numerical models work. After that, I will introduce the real-time operational forecast system, RTOS, a global ocean sea ice prediction system used by the NOAA for operational forecasts. At the end, we will discuss how model skills can be evaluated. In other words, how one can decide on whether the model is doing a good job in predicting some events. I will conclude by discussing a philosophical question, that is, can numerical models predict the future? Let's first talk about the meaning of the term prediction. What does prediction mean in scientific application? In general, prediction of a system means gaining knowledge about future states of the system from observations of the past and present states of the system. For ocean prediction, this means that we want to predict ocean variables that characterize the state of the ocean, such as temperature, salinity, sea surface elevation or sea surface height, ocean currents, and so on. For sea ice predictions, we want to know in the future sea ice concentration, thickness, snow cover, ice velocity, ice salinity, ice temperature. Let's look at this example. Let's say that we know some sea surface temperature on June 1st, 2023, and we want to know what will sea surface temperature be on June 15th, 2023. To do this prediction, we need some prediction model. And using this prediction model, we can run this model and get the prediction for June 15, 2023. Why is ocean prediction needed? The importance of the ocean prediction is obvious. The ocean is the Earth's largest ecosystem, and therefore the oceans and seas play an important role in the global climate system. The surface and deep currents redistribute heat, salt, and chemical substances around the world. The ocean provides food, minerals, energy resources. Ocean forecasting is important for navigation, fishery, rescue operation. It is also important for weather forecasting and predictions of ocean and sea ice conditions. As an illustration, during the Deepwater Horizon emergency, federal agencies and scientific community produced a number of forecasts of surface oil drift, and these forecasts were used to guide the oil cleanup operations in the Gulf. Surface oil drift trajectories are governed by the ocean currents and winds. For oil drift predictions, the ocean currents are derived from the ocean forecasts. Shown in these figures are the ocean surface currents from a model forecast on the left panel, and these ocean currents were used to forecast surface oil drift and surface oil coverage shown on the right panel. Here is another example demonstrating the importance of ocean forecasting. Safety of the offshore oil and gas drilling operations in the Gulf of Mexico depends on accurate prediction of strong currents at the production sites. The Gulf is the major source of crude oil in the United States. There are more than 3,200 active oil and gas structures in the Northern Gulf, as you can see in the map on the left. The region is frequently impacted by the loop current and loop current eddies, shown in the map on the right. These are very energetic oceanic mesoscale features whose size exceeds 100 kilometers, with currents exceeding 1 meter per second. When these eddies impact the production sites, they impose substantial drag on the oil rig infrastructure and pipes, increasing the risk of oil spills. And this is why oil production has to stop when the loop current or an eddy approaches the production site. The rig downtime is expensive, costing companies millions of dollars per day. Accurate ocean forecasts allow the companies to plan the shutdown events ahead of time, minimizing the losses and risks of accidental oil spill. To do prediction, one needs a prediction model. There are several types of prediction models that could be roughly grouped into two classes. The first class includes statistical models and machine learning models. These models derive a relationship between predicted variables and predictors using previous knowledge about behavior of the system. The main difference between the statistical models and machine learning models is that the former have a set of unknown parameters whose values are determined from the data through model fitting procedure. Machine learning models do not have specified structure. Model structure and parameters are determined from the data during learning process. Another type of prediction models, so-called deterministic models, and this type of models are based on mathematical representation of the underlying physics governing the system. There is also a hybrid type of models combining the concepts of machine learning and deterministic models, and this is a new paradigm known as physics-informed machine learning, aims at integrating data and physical laws for efficient ocean climate forecasts. In this presentation, our main focus is physics-based mathematical models. Let me give you an example of statistical model to better illustrate the difference between the two types of the predictive models. I was tasked to develop a predictive model of ocean salinity in Apalachicola Bay, shown in this map at the bottom of the slide. This is a shallow multiple inlet estuary along the northeastern Gulf of Mexico coast. Apalachicola Bay is impacted by Apalachicola River runoff, and its salinity is highly correlated with river flow rates. Also, winds and precipitation are important factors. Being impacted by Apalachicola River, salinity in the bay is lower than in the outer Gulf. This bay plays an important role in the Northern Gulf ecosystem due to its salinity regime. Apalachicola Bay supports 90% of Florida's oyster harvest and serves as major breeding ground and nursery habitat for blue crab, shrimp, and finfish. A statistical model based on a curve was developed to quantify the impacts of multiple forcing variables, river runoff, precipitation, wind direction, and speed on the salinity variability within Apalachicola Bay. And in this equation, you can see the predictors, the variables, precipitation, wind speed, and direction, and parameters. These are known parameters, and they're estimated from observations. The model predicts seasonal salinity at several locations, given wind direction and speed, precipitation, and river runoff. So all we need to do to make the prediction is to plug in the predictor variables, river runoff, precipitation, wind speed, and direction, and the model will give us the estimate of salinity at a particular location at Apalachicola Bay. Let's now switch to physical-based mathematical models. This type of models, also called deterministic models, describe evolution of state variables, such as velocity vectors, pressure, density, using mathematical formulation of physical laws and relations governing process in the ocean. Equations for conservation of mass, Newton's second law, conservation of momentum, energy, are used as the governing equations in geophysical models. Numerical prediction has several steps. In general, we start with the initial state of the system that we feed into a prediction model that is based on physical laws describing the process and the system, and the model produces prediction. In order to develop a prediction model, first we have to write physical laws in terms of mathematical statements to provide a mathematical prediction model. In some cases, depending on the type of the mathematical model, the problem can be solved analytically, like in this example shown here. Let's say we want to predict position of the ball of mass m in t seconds after it has been kicked, assuming that the ball was rolling on the ground, so this is a one-dimensional problem. The following prediction model is suggested, written in the middle of the slide. As you can recognize, it is based on the Newton's second law. Then the relation between x-coordinate, velocity, and acceleration complete the system of equations describing the problem. Note there are 3 unknowns and 3 equations, so the system is complete and can be solved. This is a simple set of linear differential and algebraic equations that can be solved analytically. The solution allows one to do prediction of the ball coordinate after t seconds, given the ball's initial position x0 and initial velocity v0. Does this mean that prediction is exact? And the answer is no, because I made several assumptions to simplify the problem and derive a prediction model that could be easily solved. Therefore, the model misses several major physical processes that exist in the real situation, such as air drag and ground friction. In our prediction, the ball never stops. The prediction can be found for the ball position even after 10 years, like an object in the outer space that can move for years across the universe. In real situation, the ball will stop after a few seconds. However, the solution may give quite accurate prediction, meaning close to real case, for the first few seconds. And therefore, the prediction is only approximate to the true case, and the accuracy of the prediction would quickly degrade with time. Ocean prediction models are also based on physical laws written in terms of mathematical statements. Models describing ocean dynamics, also called dynamical models, are based on the Newton's second law. This relation says that if a resultant force F acts on an ocean particle of mass m, the particle will acquire an acceleration a. First, it's important to keep in mind that F represents resultant force. meaning that all forces acting on particles are combined. Next, in practice, vector equations are usually written in a component form along the coordinate axis, so that each equation describes forces acting along the axis. In practice, the second law is convenient to write in the form A equals F over m, keeping all forces on the right-hand side of the equation. In this case, the equation describes acceleration due to the net force acting per unit mass. In general form, the second law provides the following set of equations describing ocean dynamics, shown in the bottom of the slide. On the left are acceleration terms, on the right are all forces acting per unit mass. Note, in the geophysical models, effect of Earth rotation on ocean currents has to be taken into account. That's why we have this Coriolis force in the equations. The governing equations for a real fluid are the Navier-Stokes equations, also called conservation of linear momentum and mass, along with conservation of salt, conservation of heat, and an equation of state. These equations involve non-linearities in many terms that make them difficult to solve numerically. These equations support many processes, for example acoustic waves, that may not be important for the regional or global ocean predictions. This means that the problem needs simplification. Several assumptions can be made to simplify the Navier-Stokes equations, depending on the type of problem solved by the model. The most frequently used assumption is incompressible assumption, which significantly simplifies the Navier-Stokes equations, making them easy to solve. Under this assumption, water particles conserve volume and density, but mass of the particle is not conserved. The two diagrams on the right illustrate the concept of compressible and incompressible fluid. Several other assumptions are listed in this slide. The inviscid flow assumption means physically that viscous shear and normal stresses are negligible. As a result, the only stresses acting on the body surface are the normal stresses due to pressure. The Navier-Stokes equation can be simplified to a form known as the Euler equation due to this assumption. And using the Euler equation, many fluid dynamics problems involving low viscosity are easily solved. Some examples include flow around an airplane wing, shown at the bottom right, upstream flow around bridge supports in a river and ocean currents. Two-dimensional approximations are very popular in the storm surge models. The ocean is viewed as a two-dimensional surface instead of three-dimensional in a real case. This assumption significantly simplifies the equations that can be quickly solved. At the same time, two-dimensional representation of the ocean provide accurate representation of the storm surge wave. That's why they are popular in the storm surge predictions. Assumptions are necessary, however, they reduce the realism of mathematical prediction models. And here is an example. We have an inviscid solution that is used to describe a flow around a circular surface. Shown on the left are streamlines, and you can think of as particle trajectories in a real flow. For inviscid flow, and the red circle is a bridge support shown from the top. Or this could be a ball traveling in the air. On the right, the streamlines from the real river flow. As you can see, in a real case, the turbulent flow develops behind the object. This demonstrates that inviscid solution is a good approximation of the flow in front of the cylinder, but it fails in the back due to the inviscid assumption. This is so-called D'Alembert paradox, or the hydrodynamic paradox. In the 18th century, D'Alembert proved the drag imposed by the incompressible and inviscid potential flow on a body contradicts observations. After implementing all necessary assumptions, we end up with a set of equations that are much simpler than original set of equations. Yet they still provide realistic forecast of the ocean. The mathematical model that we have is still complicated, and most mathematical models describing ocean process cannot be solved analytically. So next step, we need to write a numerical code to solve these equations numerically. In other words, we need to develop a numerical model. Numerical methods are used to deduce approximate solutions to mathematical model that we developed for ocean prediction. There are several numerical methods for solving differential equations, and the finite difference method has been widely used in ocean modeling, although there are finite volume and finite element ocean models as well. The idea behind finite difference method is to represent partial derivatives in terms of difference algebraic equations represented on a computational grid that can be solved numerically. For doing this, the region is divided into a rectangular network, in this particular case, of sides delta x equals h and delta y equals k. The points of intersection of the dividing lines are called mesh points, or nodal points, or grid points, and the step in size define grid resolution. The smaller the step in size, the more accurate is the approximation to the true solution, in general case. And then we use special techniques to approximate the derivatives. And some of them are shown on the right. You can see the difference approximation for the first partial derivative and the second partial derivative in space. Let's talk more about model resolution. What resolution does the model need? In theory, the smaller the better, because smaller resolution grid allows representation of small-scale oceanic processes, therefore improving the realism of the model. However, this is not possible in practice because of limited computer resources. Also, forecast models need to provide forecasts within a limited time frame, often as quickly as possible. There is no value in getting a forecast for tomorrow in 2 days. Increasing the model resolution significantly increases the size of the model and therefore the computer time to produce the forecast. On the other hand, we cannot degrade the resolution because the realism of the model will be lost. And here is an example. The Bering Strait in the Arctic Ocean is very narrow and shallow, yet this is an important conduit between the Pacific and the Arctic Oceans. However, many existing ocean models do not resolve properly the strait due to their special resolution that is not sufficient to represent the strait. Here I'm showing temperature and salinity sections in Bering Strait. On the left, observations, on the right, predicted temperature and salinity from a coarse resolution model. The model has roughly 20 km spatial resolution, and the strait is represented by 4 grid points. Comparing the figure on the left and the figure on the right, we can see that water mass structure is not represented in the model properly, as well as the flow structure. Now I'm showing temperature and salinity sections from 2 other models. In the middle, the model with 4 km resolution, and on the right is a high resolution simulation with 1.8 kilometers. Comparing to the observations on the left, we can see that the representation of the flow structure in the Bering Strait improves as the resolution increases. This is another example demonstrating the impact of the grid resolution on the ability of the model to represent ocean process of different spatial scales. These 2 figures demonstrate predicted sea surface temperature in the Labrador Sea from HICAM ocean model on September 1st, 2017. The figure on the left is a high-resolution prediction from the model with a 2 km resolution grid. On the right, the prediction from a slightly coarser resolution prediction. Grid resolution is 2 times coarser, 4 kilometers. The color bar with temperature is shown on the right. The basin has complex ocean circulation, where cold water from the Arctic Ocean carried by the West Greenland and the Labrador currents meets North Atlantic warm waters carried by the Irminger current. Ocean currents are shown with arrows in the figures, and one can notice a very distinct front between the cold, shown in blue, and warm, orange, waters that roughly follows the continental shelf slope. In the real ocean, oceanic eddies form along this front, attracting fresh and cold water into the interior Labrador Sea. Both predictions have similar large-scale circulation that looks realistic. In both predictions, the cold water masses is carried by the West Greenland current and the Labrador current. There is a distinct front between the interior Labrador Sea and the colder waters on the shelves. The difference in the two predictions is that the high-resolution model simulates the mesoscale eddies that form along the ocean front, whereas the coarser resolution model doesn't have the eddies. For ocean numerical models, we also need to choose vertical grid to represent vertical distribution of temperature, salinity, velocity in the water column. There are three basic types of the vertical grids used in ocean modeling. The first one, shown on the left, z-coordinates. In this coordinate system, the vertical coordinate is geopotential, or depth. This system is the simplest and has been in use in various ocean models for decades. One disadvantage of z-coordinates is in regions of sloping topography, where the levels intersects the bathymetry, representing a slope with steps leading to unrealistic vertical velocities near the bottom. Increasing the number of vertical levels will improve the representation of the near bottom flow, but at a higher computational cost. Next type of vertical coordinates is terrain following, or sigma coordinates, shown in the middle. In this type of model, the vertical coordinate follows the bathymetry, keeping the same number of vertical grid points everywhere in the domain. The layer thicknesses vary as the bottom depth changes. Sigma coordinates allow accurate representation of the surface and bottom boundary layers. However, sigma coordinate models have difficulty handling step topographic changes from one grid point to another. Note that both Z levels and sigma levels do not have to be evenly distributed over the water column. Often they are more closely spaced near the surface, thus allowing the boundary layers to be better resolved everywhere in the domain. And the last type of vertical grids, isopycnal coordinates, shown on the right in the slide. These models use potential density reference to a given pressure as the vertical coordinate. The system basically divides the water column into distinct homogeneous layers whose thicknesses can vary from place to place and from one time step to the next. This choice of coordinate works well for modeling tracer transport, which tends to be along surfaces of constant density. Isopycnal models have a big advantage because they, compared to other vertical coordinate systems, preserving water mass characteristics through centuries of integration. Now I would like to introduce the Global Ocean Real-Time Operational Forecast System, RTOFS. The system used for operational forecast by NOAA NCEP Central Operations. The global RTOFS is based on an eddy resolved 112-degree global ocean model coupled to a sea ice model. RTOFS with data simulation is operational forecasting system that runs daily by NCO, providing 8-day forecast of ocean state and sea ice conditions over the globe. RTOFS provides operational information, initial fields, ocean open boundary conditions to other modeling systems, such as operational hurricane forecasting models, operational global and coastal storm surge models, national wave prediction system, regional ocean models. RTOFS is based on the hybrid coordinate ocean model abbreviated as HICOM, coupled to the Los Alamos Community Ice Code, abbreviated as SICE. The interaction between ocean and sea ice models is performed via a so-called coupler, Earth System Modeling Framework. Ocean sand surface, ocean current velocities, sea surface temperature, sea surface salinity, SSH slope, to coupler where ice freeze potential is computed. All this information is sent to the ice model. Ice model sends to the ocean model ice ocean stress, short-wave, long-wave radiation penetrated through ice, salt flux, ice concentration. Both ocean model and sea ice model receive information about atmospheric conditions from operational GFS model. This includes wind vectors and stresses, incoming radiation, precipitation, air surface temperature, and air humidity. The ocean component of the global RTOFs is HICOM. The model uses hybrid vertical layers to represent subsurface ocean structure in the water column. What is hybrid coordinates? Hybrid coordinates combine all three types of vertical coordinates that I presented two slides ago. So that HICOM uses Z layers in unstratified ocean, terrain following sigma layers in coastal regions, and isopiconal layers in the open ocean. The figure on the right shows an example of vertical layers on HICOM along a section in the South Atlantic Ocean. As you can see, in the upper ocean, the vertical layers are fixed Z levels, straight lines. In the deeper ocean, the layers transition to isopiconals. Because RTOFs is a global model, it uses a special computational grid. The grid has an Arctic bipolar patch north of 47° latitude and a Mercator projection south of 47 north through 78.6 south latitude. In this grid, the North Pole is split into two poles moved over the land. This is done in order to avoid the North Pole singularity, where all longitudes converge into one point and the size of the grid cells approaches zero. RTOFs is a mesoscale prediction system. This means that it resolves mesoscale ocean processes. The computational grid allows the model to represent oceanic features with special scales from about 10 kilometers and larger, depending on latitude. And the diagram on the right roughly indicates the processes that are captured in RTOFs. All numerical models are not perfect. This means that the models cannot exactly represent the true ocean at any given time. While RTOFs is a highly sophisticated model, including a large suite of physical processes and incorporating numerical techniques that are optimal for dynamically different regions of the ocean, data assimilation is still essential for ocean prediction. Because many ocean phenomena are due to flow instabilities and thus are not a deterministic response to atmospheric forcing, because of the errors in the atmospheric forcing, and because of ocean model imperfections, including limitations in representation of physical processes in the model. RTOF's data simulation consists of multivariate three-dimensional variational data analysis that provides simultaneous analysis of 8 ocean and ice variables: temperature, salinity, geopotential, velocity vectors, and ice coverage, ice thickness, ice temperature for CS model. The analysis corrects HICOM and CS model initial conditions using a sequential incremental update cycle. Next, I would like to show some results from the global RTOFs predictions. These are the forecasts of the sea surface temperature on the left and sea surface salinity on the right in the North Atlantic. In these figures, regions of sharp temperature and salinity gradients can be observed in the Gulf of Mexico and West North Atlantic, attributed to different water masses advected by the loop current and the Gulf Stream. In the right figure, one can notice low salinity water masses along the Gulf of Mexico and the US East Coast. This is due to river runoff. Farther north, low salinity indicates the polar water transported from the Arctic Ocean by the Labrador Current. This figure shows sea surface temperature. The two lines designate the Gulf Stream fronts estimated from the model predicted temperature, the blue line. The black line is the Gulf Stream front from another ocean prediction that we use for comparison. Accurate prediction of the Gulf Stream position is important for navigation. It also provides critical information for the wave prediction in this region. A combination of strong ocean currents and winds can result in large waves, imposing potential threat for navigation. Arclux also provides prediction. The top row are maps with 8-day predictions of sea ice concentration in the Arctic and Southern Ocean. At the bottom, ice concentration derived from satellites. Comparing top and bottom figures, one can see that the model accurately predicts the ice age compared to observations. Model validation is an important step in ocean forecasting because it provides information about model performance. Typically, the forecasts are evaluated retrospectively after more observations become available for comparison. We need to understand how accurate the forecast is, how well the forecast agrees with observed ocean state, and in what regions the forecast underperforms and why. There are several ways to evaluate the model performance. Prediction versus observations, the most common and the most accurate evaluation of the model skill. Prediction versus other models and reanalysis. Prediction versus climatologies, and prediction versus observation-derived parameters. For example, volume transports in the straits, ocean heat content, and so on. It is not a trivial task to compare models with observations, and special care should be taken when model is compared against observations. One needs to understand that model point represents a grid box whose sides can be several kilometers long and has some thickness ranging from a meter to 100 meters, depending on the vertical coordinate. Satellite observations measure surface characteristics. So when we compare satellite surface characteristics versus ocean surface, it is not the same thing. We also need to keep in mind that observations unfortunately also have errors. There are many skill assessment techniques and metrics used for model evaluation. Some of them are mentioned in this slide. Here is one example of model validation. In this case, we compare ocean volume transports in the Arctic Ocean straits. The volume transports are estimated from the model prediction, and the numbers are shown in red, and those are compared with observation-based estimates. The numbers shown in blue and references are given in gray font. In general, the estimates are reasonable. However, in some cases, the model disagrees with observation-based estimates. For example, in Fram Strait, the model transport is lower than observation-based estimates. Another way to validate the forecast is to compare water mass structure in the model and ocean climatology. Here I compare vertical distribution of temperature in the model, HICOM, against ocean climatology data, taken from GDEM version 4 climatology. The vertical section goes around Greenland, starting in the northern Baffin Bay. The section is shown on the left. Vertical axis on the right figures is depth. The horizontal axis is distance in kilometers along the axis. There is a good agreement between the model and climatology. The model accurately represents the water mass structure in the subpolar North Atlantic. The examples I showed before use qualitative analysis based on visual comparison of the forecast and observed ocean fields. In many cases, the models need to have objective quantitative estimate of the model performance. There are many skill assessment algorithms that provide statistics quantifying disagreement between the model and observation. The root mean square error is perhaps the most popular model skill assessment algorithm. The maps shown here indicate root mean square error between predicted and observed sea surface height in the Gulf of Mexico. There are 8 different predictions from forecasts that use different sets of observations assimilated during analysis. The colors show the root mean square error. Yellow indicates high errors or bad forecast. As you can see, the best forecast is produced by the simulation shown in the bottom row, second to the right, indicated as TS30SST. There are almost no yellow colors, meaning that the root mean square error is quite low in this prediction. Next, we can summarize this information, computing the spatial average root mean square error, and then rank all the forecasts based on their performance. In this bar diagram, the forecast shown with pink color, also with letter C, has the best performance, and this corresponds to this forecast TS30SST. In some cases, we need to evaluate how well oceanic fronts or sea ice edge are predicted in the forecast. This comparison is tricky because we're comparing similarity of shapes, orientation, and locations of curves following the oceanic fronts or ice edges. Many techniques would not perform well for this kind of validation. One of the methods that could be used for this type of skill assessment is based on a topological metric called modified Hausdorff distance. The metric quantifies the similarity between the two objects, two contours. The metric has been successfully used for validating ice predictions, forecast of oceanic fronts, river plumes, and assessment of oil spill models. Here, the modified Hausdorff distance is used to evaluate predictions of the Mississippi River plumes in different forecasts, shown with magenta contours, versus observed plume, black contour. The bar diagram on the right presents the metric scores for the forecasts shown in the left figure. And the MHD, modified Hausdorff distance, correctly identifies the best prediction that has the closest match with observed river plume. To conclude, I would like to go back to the question posed in the title of my presentation. Can model predict the future? The short answer to this question is yes. However, a more detailed answer is needed for this question. The answer to this question depends on how accurate the prediction is expected to be, because no forecast model can provide a perfectly exact prediction of the future state of the Earth system. The Earth system that includes atmosphere, ocean, land, and ice changes in a chaotic manner. And here chaos doesn't mean essential randomness. It means that very small, seemingly insignificant errors in the initial state will grow exponentially in time due to non-linearity of the system. In this figure, I draw a diagram schematically depicting evolution of small errors in a non-linear system. The diagram shows forecasts initialized with initial conditions that have very small perturbation or disagreement among each other. This could be, for example, ocean temperature at some location. Let's say that one of these curves, the blue, represents the real world. In a chaotic system, due to non-linearity, these very small errors grow exponentially in time, and as the time progresses, the disagreement between the forecast and the true state grows exponentially. It will eventually stop growing after some time. The behavior is quite different from a linear system, where the error would grow linearly at a slower rate. Edward Lorenz, one of the pioneers in weather prediction, discovered the chaotic behavior of weather systems and introduced the concept of instability of the Earth weather system, the butterfly effect. He showed that small errors grow exponentially in time in weather predictions due to chaotic nature of the Earth system. He concluded that even a small error in the initial conditions of the prediction model would result in significant disagreement with the true state over a long period of time. Does this mean that the perfect initial conditions would result in perfect forecasts accurately representing the true ocean? The prediction would be way more accurate in this case and over a much longer period of time. However, still not exact because of a number of reasons. And the first of all is not all physical processes are explicitly formulated in the numerical models, and many processes are parameterized, for example, diffusion process. In other words, it is approximated with some relationships derived from experiments. Governing equations are simplified, so we made some assumptions to simplify the original set of equations so that they make them easy to solve. Continuum space is represented with a discrete computational grid, which results in a discontinuous representation of the ocean ice atmosphere state, which are continuous in real case. And also, this is due to numerical errors. Spurious behavior impacting physical solutions due to truncation errors and discontinuous representation of the ocean ice atmosphere. Reducing the error in the forecast initial conditions is the major factor improving the accuracy of the ocean predictions. That's why there is so much effort has been put towards improving the data simulation systems and gaining more information through observations and remote sensing about the ocean CS state and atmosphere. I would like to finish my presentation with this message that despite all uncertainties and errors in the forecast that I was talking about, prediction modeling systems are very useful and necessary tools for people, federal agencies, local communities, and industry. Existing ocean ice atmosphere prediction systems are state-of-the-art numerical models. The work on improvement of these prediction systems is ongoing, it never stops, and the models become better and better. Prediction modeling systems is a scientifically reliable tool for predictions of the Earth climate system. New approaches in numerical modeling, remote sensing, and in situ observations that soon will be available to the research community, as well as growing computing capabilities will further advance predictive skills of the models. And with this, I'll finish my presentation. I thank you all for your attention. Thank you very much, and goodbye.
Very much to Dr. Dukovskoy for his talk from NOAA. 再次谢谢美国海洋大气总署的专家的分享哦。那这个听完之后，不知道同学有没有什么样的感想呢？我来问一下同学好了。同学不知道any thoughts from the audience？ 一脸惊恐 ，they were just like, "Don't you dare come to me!" Oh, yeah. I'm just kidding. Okay. We're going to have a short break right now, and let's be back by 11:25. When we come back, it will be for the presentations of the category of professional category. 那我们休息一下，等一下11:25分。等一下11:25分呢，请大家回到会场之后，将要进行的是社青组的简报。好，那我们现在稍微休息一下，等一下11:25分回到会场。Let's have a break. We'll be back by 11:25. Thank you. 好，我们请各位同学请回座，我们下一个场次即将要正式开始了。We're about to begin, so please take your seats. Thank you so much.请同学回座哦，我们下一场即将正式开始了。Everybody, please take your seats. We're about to begin the next session. Thank you so much. Okay, welcome back, ladies and gentlemen. We now move on to the presentation. We're going to start with the professional category, okay? 那接下来呢，我们就开始正式各组的简报。我们先从这个社青组开始哦。Want to make sure that this is a level playing field for everybody. So let me walk you through the game rules first。那我们接下来呢，很快的跟大家稍微说明一下我们的这个赛事的规则。不过在那之前呢，先为各位介绍一下我们已经坐在前面的5位评审老师。And before I do that, let me introduce to you your judges. 首先呢是国立海洋生物博物馆樊彤云研究员樊老师。We have Owen Fan, Research Fellow of National Museum of Marine Biology and Aquarium. 国立台湾大学柯佳莹副教授，掌声欢迎 Professor 佳莹柯 from National Taiwan University。国立成功大学刘大刚教授 Professor 大刚刘 from the National 成功 University。国立成功大学陈章林教授 Professor 张令 Chen from National 成功 University， 以及台湾师范大学张子超教授 Professor 子超张 from National Taiwan Normal University。那等一下呢，开始之后，每一组都会先有10分钟的简报时间。Each and every team will firstly have 10 minutes for the presentation。那剩2分钟的时候呢，会听到这个铃声响一声。When there are 2 minutes left, you're going to hear the bell ring for once。那同时还会有人举牌在前面这边 ，OK？ 那时间到，我们会响2声。When time is up。We're going to ring the bell for 2 times and put up the sign. 好，简报完之后呢，会由这个评审老师来讲评跟提问，总共有10分钟。我们5位评审老师呢，1位有2分钟。那不好意思，这个老师这边也要帮您这个按铃，提醒一下您时间。不好意思啊，因为时间真的很紧凑。每位老师呢有2分钟的时间可以讲评或者是提问。那剩30秒的时候，我们一样会响铃一声 ，OK？ Yeah, and then we'll go to the judges for their feedback and also questions. And each and every one of them will have 2 minutes. So in total, it will be 10 minutes from the judges. And when there are only 30 seconds left, we are going to ring the bell once. 然后同时也会举个牌。那时间到的时候，一样是响2声。When time's up, ring the bell twice. All right. 那这个听完我们5位评审的问题之后呢，每一组有30秒的时间思考，真的非常的30秒的时间思考。After that, each and every team will be given 30 seconds to think about how to answer the questions. 那一样，这个30秒到的时候，我们也会响铃一声来提醒您。All right.Okay, you'll know that you run out of the 30 seconds. 那30秒之后呢，回答5分钟，回答5分钟。And then after that, you can answer the questions for 5 minutes. 剩2分钟的时候，大家知道，响一声。When there are 2 minutes left, you're going to hear the bell ring for once. And then, if you hear it for 2 times, it's time for you to wrap up. 如果响2次的时候呢，就要请停止简报，停止回答。Okay, that's very clear with everybody here. All right. 好，讲解完之后呢，接下来我们就赶快进入到，首先这个第一组呢，社青组，我们会有4组进行简报哦。首先呢，为大家欢迎的是城阳环境顾问，起风了。海废斗士 Ladies and gentlemen, now please join me in welcoming the first group on the professional category, Indigo Waters Institute, using microaerometers to predict the accumulation events of marine debris. 掌声欢迎。
Dear Judge, everyone, good morning. Okay. This is Ning from Indigo Waters. Today I will present how to use microaerometers to predict the accumulation events of marine debris. So in the past, from time to time, we usually see this kind of situation. The massive amount of floating litter, including styrofoam or plastic bottles, blown by the wind or pushed by the tide into the coastline. Like we have typhoon now, so we usually see this kind of situation in Taiwan. But for beach authorities, it's very difficult to predict this kind of marine debris accumulation events. So for them, it's challenging to arrange beach cleanup resources. And so usually they can only arrange regular beach cleanup, but it's very costly in money and human power. So here is our solution. We will use the microaerometer. It's like a small equipment that can record the wind speed, wind direction into this installation. And combined with 4G and IoT technology, we can the installation can transit the data to the cloud drive so that we can read those data. Plus, we use the image collecting. So when we review the image from what we collect, and we analyze it with the weather data that we collect. So reviewing this data, we try to find the correlation between the weather data and when is this massive marine debris accumulation event. So we try to establish a prediction model to tell us when will be the high peak of these marine debris accumulation events. Okay, so last year we said we had a pilot study at Beetle Port. Beetle is a small fishing port at the northeastern Taiwan, and in the past it has been a hotspot for marine litters. So we set a time-lapse camera there, and every 10 minutes the camera will have one photo shot. So from last year, we record the dynamics of marine litter during the Typhoon Shenlanue in September 2022. So you can see we set a camera above the port to record how the marine debris movement. So last year, if you still remember, so when the typhoon is close, we start to see there is some floating debris with these windrows appeared outside of the port. And when the wind gets stronger, you see there are more and more windrows accumulate here. But at this time, the port is still relatively clean. Okay, so here is during the heavy rain. So although you cannot see it very clearly, but you can see roughly there is some marine litter accumulated here, flowing by the wind. And at the outside the port, there are some styrofoam flown above the tetrapods, and they start accumulate on the rock here. Okay, so after some time, the fishing port is full of floating litter. So you can see most floating litter are blown by the wind and accumulate at the bottom of the port. And here you can see it clearly. So when the rain is smaller, most floating litter accumulate here, and you can see the volcano pumice and some styrofoam pieces and also some plastic bottles. So here is after some day of the typhoon, there are still some windrows outside the port, but you can see after the cleanup and the wind direction change, so the port it's get back to its original situation. So we reviewed the data from what the Weather Bureau collect. So we reviewed the wind speed, wind direction, and tide data. And we can see the wave height works in concert with wind speed, and because the entrance of the port is northwestern, so when the wind is northwestern, it brings a lot of floating marine litters into the port. And we also see after some delay of higher wind speed and high wave, there are accumulation events in the port. So from the pilot study, we have an initial analysis of how we can predict the accumulation events with those weather data. So this year, we will set the microaerometer to collect the wind speed and wind direction, this kind of weather data. And we will combine the image monitoring, and we try to develop a predict model that we can predict when the massive marine debris accumulation events will happen. So the monitoring image that we collect can also serve as the training data for AI image identification if other research team needs those kind of data. And we hope that this system can be duplicated to other marine debris hotspots in Taiwan or in other regions. So the local authorities or local schools, community, they can use this system to monitor the coastline nearby, and they can, according to this data, they can arrange suitable resource into the beach cleanup. So that's my presentation. Thank you.
Thank you very much to Indigo Waters. And now we'll go to the judges. Dr. Fan, 先请这个范老师。
Okay, I think developing a new technology to track to know where is the debris distribution and abundance is very good. But I believe the local people, they know well, right? They have a long life there. So it's better combine the new technology with the local knowledge and experiments. So what will you combine? And you are, that's one. The second is you are developing the predict model. So from the keynote speech, the professor developing the model. So what did you learn from the keynote speech? Okay. The third one is Beetle is your study site. But Beetle is kind of very special. It's close to the cap. So somewhere near cap, the pattern of current is very special. And based on the scientific monitoring, Beetle is one of the best coral community area in northern Taiwan. So not only the current transport the debris, they transport a lot of marine organisms. So is any method you can combine both, right? Debris is important, but marine living resources is also very important. Okay, thank you.
All right, Professor Ke教授.
Thanks for your presentation. And I have two questions. The first question is, how did you confirm the images are marine litter? Because, for example, we can see one pictures you just showed, there are also a lot of mud and sand. So how did you do that? And the second question is, so you emphasize for the influence of the wind, but how about the ocean current? Because we know in the fishing port, the ocean current is relatively complicated. And how did you think about that? And if that, so how can you cooperate with the local school and community? Because here you only suggest for the area, the micro area meters, but how can you combine the area micrometer and the ocean current? Thank you.
Thank you, Professor Liu 刘老师.
We all have the keynote speech today, and he talked about the definition of prediction and type of these prediction model. I just wonder what type of the prediction model is yours? Does it involve, a lot of, he just showed a lot of physical dynamic, fluid dynamic equation. Is your involve those equation, or anything else in your model? And then the second question is, let's say your prediction is very accurate, and you predict tomorrow those marine debris going to come ashore, and what can we do today? What is your suggestion for the preparedness planning based on your model? Okay.
Professor Chen 教授。
Thank you. I'm just give you just two questions. First one, I mean, in your model, you selected several factors, including like a wave or winds, etc. But I just want to know that why you just simply refer to the image analysis, given that we know that currents, wave, or high tides common sense that there is a high potential, high probability that the high winds or typhoon, etc., will create like the accumulation of marine debris. Well, so why you just simply refer to the image analysis? Okay, and the second is that you just mentioned that you want to apply this technology to local school or communities, but I just wonder. How these local people can learn this like the model, the knowledge applied in your in this technology. How they can learn to use this kind of the technology to use this model. Thank you.
Thank you. And finally, Professor Zhang 教授。
Thank you very much for the presentation, and yeah, really good. Just one question. What's your purpose of this project? If you really want to build on a model, I think you need to elaborate more about the what's the really factors, what be influence the, for instance, like you mentioned, you focus a lot about the wind speed, right? And not just speed, not just the wind and current. So you need to elaborate in detail what kind of factors should be included in the model. If that's the purpose for to build on the model, okay? If your purpose just for like we know if there's a marine debris right now is serious that we can plan to clean up, then I think the image is good enough. Yeah, that's good enough. You can see, oh yeah, that's a problem. Now it's a problem now that we start to plan for the cleaning the coast. Okay, so depends on your purpose, and just you may elaborate it more in detail. What's the original purpose for your project? Okay, thank you.
Okay, next we're going to give the presenter of Indigo Waters just 30 seconds to reorganize her ideas. Okay, your 30 seconds start now.
Okay, I will start.
You don't need the 30 seconds?
I'm really worried I will forget everything.
Okay, yeah, go ahead. So you have 5 minutes now.
Okay, so Professor Zhang's question first. So our purpose, we are an environmental consulting company, so we have accumulated like 4 or 5 years of coastal surveys on marine debris. So from the past experience, we found out that some accumulation events are highly relevant to certain kind of weather events, like the summer rain in the Tainan Kaohsiung part, or the monsoon after the winter monsoon at the northeast coast. There will be more marine debris. So we are very curious to find out the correlation of the weather factors and how it will impact marine debris. So that's why it's our reason to start this kind of design. And I also agree that combining local knowledge is very important. Currently, we just set these micro aerometers to the place where marine debris, where the hotspots of marine debris, but the local knowledge can also provide us like when is the high peak season of it, and I think it will help us to modify this design better. And okay, so what I learned from this morning's presentation, I think is a very difficult one for me. And our ultimate goal is to develop like that kind of prediction model, but I admit it's very difficult. So last year we only set like one pilot study, and this year we will set like 2 or 3 spots to doing this kind of experiment. But I agree that it's not enough. And so firstly, we only focus on the hotspots of marine debris. So maybe the northeast part of Taiwan and the islands of Penghu or Kinmen, where most marine debris accumulate. So that's why we want to try to find like this kind of system. And how the local community will use this kind of system, because we are still like in the experiment process. So ideally, like when we develop this kind of model, we hope that it can send like alert in advance of this kind of weather events, or when the beginning of this kind of weather event, it can use the weather data of rainfall or wind speed, wind direction to tell those local authorities that there might be some accumulation events happening, so they can arrange what is the suitable equipment and what's scale of the human resource to do the cleanup. So that's what we want to solve. And for Professor Fan's question, yes, the current not only brings marine debris but also bring a lot of nutrients. Yeah, so we are still in the experiment, but we hope to work with the current experts to use the current models to tell us more about why this kind of phenomenon will appear. And because in the past we see a lot of pumice or floating algae and marine debris will appear together. So it shows us that this kind of floating things will appear in a big group. So I believe there is some correlation between this kind of stuff. Okay, I hope I answer all of your questions.
Yes, thank you so much. Once again, let's hear it for Indigo Waters. Thank you. 再次谢谢. Is it okay that we put a pen and some paper at the podium, because it's very challenging to remember all the questions. Indigo Waters, we were very impressed with your memory. Okay, yeah. So 工作人员是帮我们准备那个一些纸跟笔在这个讲台上。那等一下每一组简报的时候，板子，对，有纸板，或者是有那种立板这样，他们可以一边听一边记。但就是老师的问题，有些他们可能没有记住，这样没有回答到也有点可惜。OK， 所以我们准备一些纸笔好不好？那看看有没有那个 clipboard。OK，yeah。有，他们不一定会一个人上来，因为他们有的是整个都会上来，这样他们自己有分配好了。All right, okay. So thank you once again to Indigo Waters, and now we move on to the second group in the professional category. We are going to invite Prince Wang and his happy friends. OK， 我们有请王爷与他的快乐小伙伴送走塑胶鬼，掌声欢迎。Let's welcome our presenter. All right, you have 10 minutes for the presentation.
一直麦完就好了。好，那等一下，然后上表是讲到从左边下来这样。
哦，好。
好，谢谢。
Oh, okay. Hello, everyone, the distinguished guests, and ladies and gentlemen. We are Wang Ye and his happy friend. And this time our goal is to promote the local culture of Donggang by combining Wang Ye Festival and a marine cleanup activity. And we hope to promote the cultural awareness and integrate the ocean conservation into local community. And our slogan is, here is Wang Ye Kang, the ocean will be clean from now on. Okay. And where's the resetter? Okay. Where?
往哪边呢? Okay.
Okay. And when we talk about Donggang, what will you think of? Maybe it's the maybe it's the seafood or where is here? Here. 上面好。or tourism, go to 小琉球. Over the ball, I will mention later. Okay. A little bit latency. And today I'm going to talk about is a special ceremony in Donggang, which is triennially, and it's called burning of the Kimbo, the Xiong. And during the ceremony, all the people in the town will participate, and people will make a big wooden board, and people will carry wait a second. People will carry and sell it around the town for a week. And at the last day, the people will gather at the beach, and the board will be burned on the beach. Yes, will be burned on the beach. Yes, and wait a second. How use? And actually, here's the thing. Wait.
It seems like the presenter has a difficult time using the yeah. Sorry about that.
Oh, here's the thing, when driving through my very own community and seeing the thousands of plastic bags lying limply on the street and on the beach, it really bums me out. How to say that? It really bums me out. We often hear people say Taiwan is an ocean nation. The place where we live is surrounded by ocean, right? And you know what? The ocean pollution is happening. Nothing is going to fix the masses of plastic bag is by polluting my hometown or even the world unless we take a step. Yes. And as a Taiwanese, especially a student trained by higher education, we always think about how to do some, just say, there's so many ocean conservation solutions in the world. How to do something different and what can we really do for the ocean conservation? And occasionally our team member just come across and say the more local is more international. 就是说越本土就越国际。我刚刚讲咱台湾人就是要这款观念就对了，对。So our team member decide to combine this local cultural ceremony with the ocean conservation. And here's how our proposal was born. And our next partner introduced the next page. Yes.
This is our proposed solution. The first part, use tourists for employment protection. And the second part, sustainable transformation of seafood culture. Our festival allows attendants to collect garbage for special souvenir called Wangma. Promoting environmental responsibility, we have designated West Station for proper disposal of general waste, recycling, and paper utensil collection. Local business support sustainability by encouraging the use of eco-friendly cups such as U-Cup, and use the app to borrow the cup. And also, local business will offering discount to those who use the eco-friendly cups. By embracing this cup, festival goers not only save their money, but also share their commitment to a greener future. Next is a local seafood science promotion. We aim to collaborate with the local food and beverage industry to promote sustainable fish cuisine, creating opportunity for science education, industry innovation, and transformation. As you can see, this is our sustainable seafood shopping menu that we will provide to both customer and local business. We collaborate with respected speakers such as author Liao Hongji, an executive from the IOC, who delivers insightful lecture on marine sustainability and the importance of responsible behavior. E-book of this lecture are distributed to spread and inspire action. Our goal include increase the amount of waste disposal, increase the proportion of sustainable catch meal sold, and promote interaction between public and private sector, and also give new value to visible culture. Together with Prince Wang and his happy friend, we can create a cleaner and healthier ocean for future generation that make a lasting impact and building a sustainable future. Here Prince Wang comes. The ocean will be clean from now on.
Thank you for your attention.
Thank you.
Thank you very much. Thank you. And now for the questions, Dr. Fan Lao Shi.
Okay. I think your presentation is very good. So I am very impressed. You are trying to integrate the culture, the environment, the tourism, the food. Okay, and you say this is a local activity, but you're trying to have the global impact, right? So based on your experiments and knowledge, you talk about Donggang or 小琉球. So where are those other places highly similar to Donggang and 小琉球, this kind of coast or island? They have similar culture and environment or tourism, seafood challenge, and you can work with them, right? Became a teamwork in Taiwan. And what's the other country you think they are also very similar to Donggang or to Taiwan, and you can work with them, became an international team? Okay. Then, okay, that's my only one question. Thank you.
Thank you, Professor Ke.
Thanks for your presentation, especially you use the Taiwanese language to share for everyone. And so I only have the one question for your team. This question is because I feel that you spend a lot of time to introduce the Burning King Ball event. So I think this is a very important cultural event in Donggang and especially in southern Taiwan. But I haven't hear you discuss about this event because you mentioned when they do this kind of the event, they were induce and develop a lot of the plastic waste. So can you also let us know, so how did you incorporate your idea to this kind of the event, like the Burning King vessel? And how did you think, so how can we decrease the waste from this event?
Thank you, Professor Liu.
Oh, okay, I guess my first question is similar to Professor Ke, that the King Bowl Burning Festival, you probably been there. And my question is, after the event, it probably going to produce a lot of, I see in your presentation that those debris or those remain piling up on the coast. And is there any coastal cleanup activity after the event, and what's the extent of the impact? Were you been involved in the coastal cleanup after the event, and what did you see there? And then the second question is that it seems like you have two goals. The first one is to bring up the tourist awareness, and then the second one, you provide a sustainable seafood menu. But my question is, how do you implement those plans? I mean, do you have a place and to get the tourists in the place, and then you're gonna start an educational campaign? You're gonna have a course deliver there or anything else? Because you didn't tell us how you're gonna do that, do the action plan to, to reach your goal of your goal is to, bring up tourist awareness.
Professor Chen?
Thank you. I just wonder, I mean, you talk about several ways try to solve the problem, like to reduce the waste or try to promote the sustainable seafood purchase, right? But actually, I'm not so clear about what's the specific problems, okay, you found arise from this festival. Okay, and these problems hadn't been solved by the local government. Well, this is my first question. I think you maybe just reiterate or specify what's the problem, exactly the problem that have arisen from this festival. Okay, and the second question is that you try to promote the campaign of sustainable seafood purchase or cuisine, etc. But how about the tuna? Do you think this tuna is a sustainable catch? I just want to know your comment or your idea. Tuna is a sustainable, bluefin tuna. Bluefin tuna is the sustainable. In your view, bluefin tuna is the sustainable seafood. Okay. If not, okay, how can you promote this kind of sustainable seafood given if you are in the festival? Okay, and the third question is that given that there is a huge crowd, okay, at this festival, so how can you convey, okay, or persuade these tourists into doing the things that you want them to do? Okay, thank you.
Professor Zhang?
I appreciate the two concepts in your project. The first one, eco-friendly cups, okay, and the second one is sustainable food.
Menu.
Seafood. That's a very important two concept. I think they are great, and I also kind of is inspired by another concept. I think that's really, really important. You mentioned about local heritage or local knowledge, not just an event, not just the burning boat, that kind of event. Can you offer some more in depth about the local knowledge, and can integrate it in all your events or your project? Okay, yeah.
Okay. Wang Ye, do you need 30 seconds?
Yes.
Okay, 30 seconds start from now. Okay, now it's time for you to answer the questions. You have 5 minutes.
So for the first question is what's 小琉球and Donggang, what's different culture and the food, and what's the place had the same culture and the food, and I think and as I know is just like Donggang, Nanzhou and the 小琉球, they have this kind of festival, and we didn't to discover other country, or do they have the same this kind of culture, and we were to search, sorry, and then the second question is we spend a lot of time in Donggang and
没有跟动，又在讲。
有一些 local 的。at Donggang, I want to say actually I'm how to say that influencer in Donggang. Yes, I really involved. How to say it? I'm the 八嘎囧。我来跳八嘎囧。I'm out. Yes, I'm not so. It's more easier to talk to the older 长老 to and really can that we to implement this program. Yes, and 有很多是那个有没有其他的兴趣什么意思写什么？There's a lot of garbage on the beach, and actually, we have a plan is to have a beach clean out activity. Yes, and which some is具体可以怎么作为？你讲。
To promote the seafood menu, we'll try to put in a local business store, and instead of this, we will put it on the app. We combine with the eco-friendly cows.
我讲了 and we also have an idea is that I don't know how to say that word 就是讲顶头有迄个凉水车就这 provide 凉水车 and we think we can just give the participate to people then the cups and then can to have a water, yes. Oh, and now it's also yes. 你怎么去 cover 这什么东西？
就是有没有更多的东西？就是刚刚其实跟前面聊的。
哦，什么意思？
例如说作者这样。
Can the last professor what is your question?
Local. Just one. I think it is important to. Yeah, traditional knowledge. Okay. Yep. In Donggang area, and it's related to or helpful for environmental protection or reduce garbage that kind.
Actually, during the ceremony, and we think if the tourism can just take out the garbage and they can to exchange 王码就是这种王码 yes 正品 yes and 不知道还有差不多 okay.
All right, so thank you once again to 王爷与他的快乐小伙伴 Thank you so much. 王爷凉水车是什么啊？所以凉水车是什么？我这是个人好奇，想要问一下安尼呢。
就是会有以前传统凉水车就是一个橘色的那种，然后里面放大冰块，然后
Okay. All right. It's like a mobile fridge. Okay. Okay. Thank you once again. All right. We have one more team before we take a lunch break, and that will be Azure Alliance, Taiwan. 那接下来呢，是我们午餐休息之前，还有一组社青组的这个团队要简报，让我们欢迎台湾湛蓝海洋联盟，掌声欢迎。
Hello everyone, ladies and gentlemen, before lunch. Okay, we are in this year, the Ocean Challenge will bring the topic about Asia Fighter, bridging local community and clean ocean. So why we choose this topic this year, let me explain. Okay, so Asia Alliance is a non-government organization
formally established at 2019, but the original idea could be traced back at 2016 with the Lego model. So during this year, we pay our effort to improve the marine removal rate, the efficiency. So we built a different type of AZ. And from this year, we got a whole new AZ 3.0 with the autopilot system. In this year, in this competition, we will bring the story from the AZ 2.5. Okay, so let me bring everybody back to where we began. This is the beetle fishing community, which we stand with the indigo water. So beetle community is a very lovely fishing village, but without a regular marine collection or removal activity by different sectors. So we believe if we do a pilot project here, we can get more pure experiment and data. So, okay, so here is where beetle located, and with the village is very small, so with the average normal resident with 200 populations. So here is our 14 dock, and we do a clean mission by AZ 2.5. So how many debris or how many removal rate we can achieve? So back to the 2019 at Badozi Fishing Port, at that time we got the AZ, I would say 0. So in that time we got approximately 3 kilogram per hour removal, marine debris removal rate. And in that year, we achieved to 84 kilo per hour, which we improve our efficiency almost 30 times in 4 years. It is an important number because we pay a lot of effort on it. We have no engineer, so we spend a lot of time. But what those numbers indicate or means for the local, those numbers indicate we can solve the marine problem. I believe it's no, because everybody knows that if we want to well management the waste, we need to both clean the water, clean the debris, but also turn off the faucets. So every single day we ask a question like this: is it possible for innovative technology to more, to improve the whole situation of the marine ocean? For the marine. So we asked the 2 questions in beetle. The first one is, do local community really care about marine debris? Or they will say, oh, it's just a normal situation daily. Or what do they think of the innovative technology like AZ to deal with this kind of efforts? So 3 major contributions we want to summarize the work in past 6 months in beetle. The first one is we actually clean the marine debris. On the 14 water debris, we collect by AZ, but also we invite a lot of companies such as Yangming Haiyun to go into the local to do their ESG, to do the beach cleaning with us together. And third, while we have time, we will do the public environmental education. And also, we spend like 3 months to interview the most of the residents to ask them what they think of this kind of issue. So before I bring the data out, let me show you the day of our beginning. So at the beginning of the day, we will collect all the environment factor, which including the weather condition, like wind speed, wind direction. So in the future, we can kind of analyze if any the amount of the marine debris can have the correlation with those environment factor. And okay, so then we will go into our 14 dock and we'll release AZ. So before you release the AZ, you need to pull up the rope. So it's kind of hard work. So while we operate the AZ to collect the marine debris, it's actually very eye-catching. So a lot of residents or tourism will stop by and say, oh, what are you doing? What kind of boat, vessel are you catching the fish? They ask a question like this, but in some, we got a friend with the local, so Coast Guard sometimes will ask us, oh, how was the catch today? And just be careful to keep the safety distance from the ocean, okay? So they always remind me of that. After we collect the debris, we will separate, calculate, and record as detailed as possible by ICC, based on ICC marine debris category. So for the debris, like good quality of styrofoam and PET bottle, we will package together and go into a circular economy. And for those who cannot recycle, we will just package and go to the trunk. So what kind of debris how many debris we collect in past 6 months last year? We collect totally 5,193 kilogram marine debris. So the removal rate, if you remember the number, it's around the average with 84 kilogram per hour, but we hit the highest at around 120 per hour in October. So because of a lot of volcano farmers are coming with the debris, but if we with those data, we have an index of relative importance of marine debris. We got a lot of PET bottle, and followed by different fish gear, which including fishing line, fishing net, and different buoys, and with the plastic bag, styrofoam, and followed by glasses bottle. Okay, and so the lost debris really, bother the local resident. So the answer is yes. According to our interview during the 3 months, 90% of our interview, they think the marine debris will bring a negative impact of them. And with the different aspects, we can see from the ecological environment, and they concern about the human health impact, and also ecological losses and psychological feeling. They feel bad when they get up and see a lot of debris in front of their house. But if that means AZ will be really welcome at the first time in the local? The answer is no. At the first beginning, Fisher always say to us, "Oh, AZ just too small to clean the debris." And the diners say, "Is this a project led by government? I don't believe those girls who will spend their own money and own time on cleaning the debris in the other community, not even, the village we live. And are you staff from Yangming Haiyun Company?" And the resident says to us, "Oh, marine debris is a seasonal issue. We have a magic. The wind will bring the marine debris out." Well, scientifically, they are right. But the wind will bring the marine debris out, they will bring also in. So here is a video, Bito village just hit by the typhoon Hanoi at the last September. So it's a very big challenge for us because the volcano farmers will really hurt the AZ too, but it's also a very great opportunity to help us to build the relationship with the local people, especially fishermen, because Bito Fishing Village is, they depend on a lot of economy on the fishing, so their vessel will be also hurt by the volcano foam. So in this case, we build a lot of good relationship. So after that, we reviewed after 3 months, we got a very significant score in the 4 aspects. The first one is we bring their discussion and raise their attitude about the marine debris. They discuss the marine debris issue in the community, which is not happened a lot before. And the second one is we show them the community can really do the ESG and action in the local. And third one, we really do clean debris, and we doing very well. And the third one is they start bringing a lot of different opinion to us. They look at the YouTube and say, "Hey, I thought the other machine out abroad. You should learn from them, or you should educate the angler, not lettering." So here's all different opinion offered time by time by the local resident. So Fisher said, clean the volcano farm is really help them. And while they see our active in the port, they will pay attention on marine debris. And the diners say, even though they will not throw actively, but they will pay attention to keep the marine debris will not go into the ocean. So during that 3 to 6 months, we believe the answer is yes for us. Through the innovative technology, we can not only collect the debris, but also drive their motivation on their own environment, like turn off the faucet. Yeah, thank you. Fight together for Asia Ocean.
Thank you to Azure Alliance. Now for the questions, Dr. Fan.
I'm very impressed by your team continuous work on this issue. Actually, you are getting better and better. Now the efficiency is 30 times of the cleanup of the debris removal, right? And also you change the people's attitude. Okay. So what's your next plan? So how to make, for example, is it more government or private company or local community, they support your team financially or manpower work with you, okay? And compared to other cleanup method, what's financially, what's the return on investment for your as you compared to other similar way, or maybe clean the debris from the shore might be I don't know. Okay, then Beetle might be looks a very promising harbor, right? What's the next harbor, or what's the next area or country you think you can apply this project? Thank you.
Thank you. Do you need this? Okay. Professor Ke?
Okay, thanks for your presentation, for this wonderful introduction for the AZ. And so I have the several questions for you. The first question is, can you let us know what is your frequency for collecting marine debris in the Beetle fishing port? And because it would be represented how much and how many marine debris that you can collect. And second question is, as you collect from all your like the community or residential residents, and they already mentioned that because the AZ is so small, and how could it can do the very good job for the cleanup? So what is your plan to improve this? And the same as the similar question is, you also mentioned about the marine debris is seasonal issue, and how will you do in the future to think about the effective way to clean the marine debris in the Beetle fishing port? And the final question is, I think because you have the very good structure for this machine and all the strategy for the community, and can you clarify again for your future action plan for us? Thank you.
Professor Liu?
Okay, I guess I see the Azure Fighter several years ago in YouTube, and then after that, every time I see it, it get bigger. So you just say right now is like 2.5. Okay, and then my question is that how big you gonna scale it by your final goal? Because it seems like you're gonna improve it a little bit, year by year. So what's your final goal? And then the second question is, I believe you probably see those garbage collecting vessel. I think there is one in Port of Baltimore. You probably see before, and I heard about there is one in Port of Kaohsiung. They also has a garbage collecting vessel, but manually. So can you compare, the advantage of your Azure Fighter to other model you see, in the market?
Thank you, Professor Chen.
Your presentation here, I have some questions for you. First, it seemed to me that this device has been improved, okay, from maybe 1.0 second and third version, okay? So can you just specify, okay, what progress has been made in technological terms from 1 to 3, and what remains to be solved in technical terms, okay? And the second is that I have a similar question with Professor Fan. What's the big dream, okay, you have, okay, in creating such device? You want to sell them to local communities, or you want the local governments or harbor authority to buy your products, etc. Okay, even though we know that the government has some spending on collecting debris, floating debris in the harbors. So how you can persuade them, okay, to use your device, given that this is a routine job now done by them? Okay, this is the second question. And the third is that quite different to your topic because your topic is try to bridge the local communities with the ocean clean, a clean ocean by using the Azure. But we know that there are several ways to have the local communities engaged in cleaning in clean water, clean ocean activities. So why you think that the Azure is the one of the alternative that can be accepted by the local government? Thank you.
Professor Zhang?
Just the term bridging, I'm very impressed because from my perspective, the importance of your project, you put more on the bridge, the community with environmental education or interview, survey, and to kind of wake their awareness, okay? And how about the AZ fighter? So what, okay, just compare the important meaning of the AZ fighter and also the bridging the community. What's really your team focus on in your project? Okay.
Do you need the 30 seconds or?
Yeah, I mean, 30 seconds.
Okay. Your 30 seconds start for now.
It reminds me like the business already finished. So many professors sitting there. Okay, let me think of it. Okay, so yeah, I think I'm ready. Yeah.
Okay, 5 minutes.
Thank you. So first of all, Professor Ryan's questions. So thank you. And actually, our next plan will be we will trying to develop the more appropriate AZ due to based on the cost down because while we solve the environment problem, we need to notice that it's like a very high moral because everybody need to keep their life like they're healthy and they need to earn the money for living. So to solve the marine problem, we need to be like efficient and not expensive. So for the next so they have a different perspective. So the next step, we will cooperate with the different team, like the university or the presentation we hear this morning, very difficult one. Could we improve or apply the prediction system in our AZ and make it more efficient? So that first one. And second one for the finance. So for the finance also, I believe it's also Professor Chen. For the finance, it's actually very difficult because we need to cooperate with different company. And we have 3-4 more staff. So we need to deal with a lot of administrative work, and also we need to clean up the ocean and do the educational activity. So that is a very biggest challenge for us because while around the world there are more than 60 different facilities of the marine debris collect, which Professor Liu also bring that. So while we don't improve ourselves very fast, we'll be stopped by those administrative work and finance challenge. We'll be very, very back forward compared with those company or NGO who with a very big funding. So that is a challenge for the finance. We in this year we have the Google Sea Fund Foundation. So we were chasing a very big and stable funding for in this stage. So for Professor Guo, it's the question is how could we improve the efficiency and with the weather and the other condition? It's like we were trying to cooperate with a different team, like a very professional scientific team, and we will ask them their needs and we collect the data from the field as much we can, and we discuss how to improve like the weather and the other condition could improve it. And for the skill, it's like we build like bigger than bigger. So there is no perfect machine for every water. So for example, in the lake, in the river or the open ocean, they have a different skill facility. So we we will say in this stage, we are trying to coast down and we're doing in the fishing pool because in Taiwan, in mainland, we have approximately 50% of artisanal reef. So we have like the highest density of the fishing port. So the first step in Taiwan, we do in the fishing port, but we dream bigger. So in the future, our plan is we're trying to solve our machine in the Asia Pacific region by 2025. So we need support. And for the 2030, with the government and the vision of whole world, we're trying to solve the marine debris problem step by step. So in that conclusion, I will say the Asia fighter, why we use the Asia fighter is because we are not a team to do a beach cleaning. There are a lot of amazing and outstanding team doing the education stuff in Taiwan. We try to build a different market, and we want to people don't afraid of innovative technology like. Now a very complicated mode, you are afraid to use it. We want to let AZ be a friendly, efficient technology to build with the people and clean ocean. So I believe my time is up. And then thank you.
Thank you so much to Azure Alliance Taiwan. Thank you. All right. People down there might find it a bit nerve-wracking to come up here to do the presentation. You cannot see the judges. I have to tell you, they all look very nice and very supportive. All right? Okay, so don't be nervous. Just come to the stage, share what you think and your stories. Okay, it's going to be fine. All right. So everybody, next we're going to have a lunch break. We'll be back by 1:35. We'll be back by 1:35. That's due a 1 hour lunch break. Please go to the second floor. We have buffet lunch ready for you. Everybody just go to the second floor. We have lunch ready for you and be back at 1:35. We have more presentation for you this afternoon. See you later. Thank you.各位同学，接下来呢，午餐休息的时间，请大家就移动到2楼，请大家呢移动到2楼。我们外面有指示牌，也有工作人员会引导您到2楼享用午餐。下午呢是1点35分，1点35分呢，我们会再次开始，请各位贵宾准时回到会场，谢谢。等一下，中午休息的时候，会场会有工作人员吗？我们老师或者是同学想问说，他们的电脑或包包可以留在会场吗？有，再麻烦帮我们回应一下哦。可以。好，老师电脑可以留着 ，OK。工作人员应该会轮班啦，留在会场。但是真的贵重的物品还是请大家带着哦，谢谢。 提醒各位同学，我们下午场再过3分钟，再过3分钟之后呢，即将正式开始了，请大家准备回座。In about 3 minutes to begin the afternoon session. Ladies and gentlemen, please take your seats. Thank you. Okay, welcome back, ladies and gentlemen. We hope you all have enjoyed your lunch. 欢迎大家呢继续回到我们的下午场哦。那我们的社青组呢，还有最后一组要来简报。And we have one more group from the professional category. And so next, please join me in welcoming the magic membrane to the stage. 接下来呢，我们就掌声欢迎魔镜之魔术师，有请。
然后这是简报的。
Oh, okay. Good afternoon, everyone. 13 is the magic membrane from the National Taiwan University. Today, I'm very happy to be here to share the interesting study to break out the ocean challenge. In this research core value, we think we utilize the nature-inspired microplasma system to fabrication the quantum material from the plastic waste, and also combine with the biomass to form the magic membrane. By the solar energy, this can produce the pure water from the ocean water. So in the following talk, I will briefly introduction the water develop and the waste plastic, and also explain why this material can useful for the distillations. So plastic is a thin, strong, and flexible which bring our continuous life. Unfortunately, uncontrollable use and disposal of waste plastic have already affected the ecosystems. So in the ocean, there are the 18% of our marine debris is the plastic-based material. There are 1,300 tons of plastic production in every year. Also, the plastic took a long time to degrade. So the most importantly, the waste plastic it costs the ecosystem $80 billion in every year. So plastic is around the world. So how to relive the plastic is an important issue. So due to the major of chemical engineering, so we deeply analyze the traditional process, how to recycle the plastic waste. So the first, the process will cause the microplastic particle in the secure the living bodies and lead to the production of toxic bisphenol A, so which are harmful for the human bodies. So from the one day, the lightning from the sky. So we think we can use the nature-inspired mycoplasma system to solve the plastic problem. Mycoplasma is the green and low-cost manufacture process, and this is the continuous process can apply in the industry intermediate. The most important, the mycoplasma is the 4R reactor. This contains a lot of SDGs issues. So this is a video under the mycoplasma system. The PET plastic particle convert into a quantum material to achieve the reduce, reuse, recycle, regeneration in one reactor. One reactor per hour can decomposite the 2 PET bottles. So this is a small scale. We further design the mycoplasma array. One reactor can decomposite around the 70 PET bottles and also design the continuous process. This mycoplasma can decomposite around the 200 PET bottles per hour. So the magic the mycoplasma can convert the PET plastic into the quantum material. So now we give the material characterization briefly. So the first, this material is only the 2 nanometer. This is the quantum material. And we also introduce this the chemical property. This is very suitable for water develop. And the physical property, this contains the optical property. This is mentioned, this quantum material can perform the lamp. And even now, there are the quantum screen and quantum TV generation. So after this, we use the graphene quantum dye and the plant and the biomass to form this the sponge. And this sponge can do a lot of application because it contains the flexible conductivity and the hydrophilic. But now we focus on the ocean. We focus on the waters. So water is the critical resource from the critical resource issue. According to water resource in situ, more than 1 billion people around the world don't have enough clean waters. So seawater represents 97% of all the water resource. And Earth's surface of 70% is covered by the water. So how to reduce the water is the most important issues. So there are a lot of traditional process. The one is reverse osmosis, and the second is the multi-stage fresh distillation. There are a lot of drawbacks. For example, the byproduct wastewater is more than the pure water. This mentioned we will give the more step to solve the wastewaters. And also the byproduct wastewater is the high concentration of salt. So this will destroy the pipe and pump. So there are offer the ultra high operation cost and energy extensive process. So we think how to solve this problem. We design the membrane distillation as a solar energy. This is very easy. It's just use the vapor mechanism. We just put the membrane and between the hot flow and the cold flow. Under this video, you can clear to understand why is the membrane distillation. So in this membrane, the seawater is on your left hand, and the solar will infuse the membrane pure waters, and we can collect the pure waters. So this is a very easy mechanism to get the pure water from the seawater. This device contains a lot of advantage. So the most important is the low temperature and the pressure operation. So, and this is the low order energy use. So after the next part, we will use this material combine this device to get the pure water from the seawater. So welcome the Andrew Wu.
And then we'll introduce our device. And the solar the simulator is to simulate the sunlight to hit the membrane, and the pump is to drive the water flows. And the weight balance is to calculate the permeable flux of the membrane, and conductivity meter is to measure the purity of the water. And by our invention, low energy is needed to generate green water by a simple process, realizing reuse, recycling, reduction, and regeneration. And we utilize the photothermal effect, exhibiting high anti-scalding properties. In general, RO cannot treat highly concentrated seawater, resulting in the discharge of the salt water back into the ocean. Unfortunately, this discharge will harm the marine ecosystem. However, membrane distillation has the capability to deal with high concentrated seawater. By employing membrane distillation, the remaining product after desalination is extremely high pure water, extremely high salinity water, which can be easily purified without discharging it back into the sea. And this approach mitigates the potential damage to the marine ecosystem. Furthermore, a unique procedure provides an exceptional mechanical strength. It means that it can operate for an extended period without replacement and ensure its long-term reliability and cost effectiveness. And it can produce 60 liters of pure water per day. Our invention not only can solve the water crisis, but also realize several SDG and reduce carbon dioxide emissions. And in summary, our invention provides an environmentally friendly technique that can obtain water resources from the ocean while conserving the marine system. Instead of using electricity, we achieve significant energy savings by utilizing infinite solar energy. And by trading carbon credits can allows us to create more revenue while improving our business image. By our invention, climate change can be suppressed. And to promote our product in various industry and daily application, we can utilize industry academy integration to show our potential in business cases and combine with 5G IoT to measure and monitor the parameters that operated in the marine desalination process, such as temperature and salinity, to ensure that our system is operated at its optimal state, and improving efficiency and reducing cost. And our solution is a fast and green techniques that combine economic, society, and environment. Our invention can solve water resource crisis and reduce the carbon dioxide emission. Thank you.
Thank you very much to the magic membrane. And now for the QA, Dr. Fan.
Okay. Looks very promising for this magic membrane project. So it sounds like a high technology for me. So I'm wondering, is this project, this idea, the concept has been proved, and then because you are, it sounds like you are a student in university, right? So your professor or your department, what's their financial support for your project? And is any private company or industry they are highly interested? And if actually for this challenge there is a award, $100,000, right? If you receive this $100,000, what's your plan for this budget? Thank you.
Thank you, Professor Ke.
Okay, thanks for your presentation. I think it's really a magic presentation with the good logic and structure. So I have the question is especially related about, so I'm very happy that you have this kind of the design, especially for how to remove the microplastic. However, I think it's also, did you have do some work like, because this kind of the design is also in water or in no matter in freshwater or ocean, actually there are so many microbial organisms. So although it's very good to remove the microplastic, and how about the microbial organisms? So I think that it's good or bad for them. And so, and further, so when you set out for this design, and where did you think you will put this kind of the product? So in the between the freshwater and ocean, or you want to put the freshwater, I think it's also very important for us to know how you will put this your distillation to anywhere, and let us know where you really want to remove the microplastic or other marine debris.
Next, Professor Liu.
Well, I guess we all know that there's a typhoon on the right-hand side of Taiwan, and today it does not bring in too much rain. And more bad news is this year is El Nino years. So scientifically, we are not expecting much rain this year. So your proposal come timely for the water shortage situation in Taiwan. So my question is, it seems to be a promising technology, but as you know, it's not a commercial technology. So do you think how long it's going to take for this system to scale up to be a commercial technology? How long it's going to take? And then the second question is, I think in the last slide of your presentation, you do a side-by-side comparison between this technology and membrane. And it looked like your technology is better than membrane technology, but this comparison, is it based on experimental data? And I was wondering, in your experiment, what's the flow rate of your experiment? Because right now, Taiwan gonna build the first large scale desalination plant. And it is about 100,000 tons per day. So when everything scale up, the cost effective is gonna change it. Especially when you compare it with membrane technology. Can you comment a little bit on that?
Thank you, Professor Chen.
Thank you. Here I have two minor questions for you. The first one that it seemed to me that in your presentation you just point out two major selling points. One is the solar derived, right, and the second is the biomass membrane. Okay, so I just wonder, the first one question is that, so you mean that the solar derived membrane distillation means that you don't need electricity to run this device without any electricity? I just want you just clarify on this point. Okay, and also you mean the biomass membrane, it means that no waste produced, they can be decomposed totally in nature. Okay, now this is the first question. And the second is that how you can demonstrate your device has the same or even better function in distilling seawater than compared with traditional ones. I mean that is that your device is to produce better water quality than traditional ones. Okay, so you may be specify on this point. Thank you.
Professor Zhang.
The solar derived concept, and also the biomass membrane is good concept too, and put together is greater. Okay, and also the membranes distillation is good too. I'm wondering what's the creativity, what's the original idea of the whole, so many concepts. What's your original ideas? That means you have to add some reference about all these concepts. And of course, you also offer the whole stock mechanism for your project. I think it's good too. So just just focus on what's your original, you think is important for your project. And that's good for my reference. I don't know how to evaluate your efforts. Okay.
Yeah. Do you need 30 seconds to go through the questions a little bit? Okay. Okay, your 5 minutes start now.
Okay, thank you for all the judge question and the comments. And I think this is a good idea technology to do the distillations. And because this just the device and this just use the microplasma nature inspired system to solve the plastic problem. So this is my highlight, the first one. Microplasma can develop the right can convert the PET bottles into the quantum material within a minute. And the second, use the quantum material can contain the optical property to do the solar derived application. So we are highlight the two technology and present this contents in these seminars. So in the future, we think we can the solar panels, and we can add the solar panel and put the membrane distillation into it. So we don't have any power from the electricity. We just use the solar energy to give the electricity to the pump. So this is a circular economy relationship. So we can use the no electricity and we can run the seawater to get the pure waters. So the first judge questions, the potential just in the for example the cost calculations, because we create the first microplasma systems. So we want to use the recycling to get some money, and because we have already calculation the cost, we have already to we compare with the commercial product, and the 1 gram graphene quantum dot, we can the net income is the 1,000 NT dollars. So maybe we can to recycling the 1 PET bottle, we can get 50,000 NT dollars. So we think we can put the income and to put the income money to the membrane distillation, and we can create a green world and a circular economic. Thank you. And
you mean membrane RO and MD is a totally different mechanism, but MD is membrane distillation. It's combine the advantage of membrane as distillation. And RO, because we have to know the mechanism of RO and the membrane distillation. RO is to separate the water through the osmotic pressure difference, but membrane distillation is to separate by the difference in vapor pressure, and the vapor pressure is resulting from the difference temperature. So RO cannot treat highly concentrated water, because if after the desalination and the seawater will be salinity will be higher, and the energy consumption will be proportional to the salinity. So if you want to do more salinity about in RO, it will cost a lot. But MD, membrane distillation, is the vapor pressure is determined by its temperature, not the salinity. So despite that, let's say after the desalination, the seawater have a high salinity. It can operate it at a low cost. And about the membrane needs some electricity, but just a little. In experience, we use the pump to drive the water flow. It's to simulate the wave in the ocean. But sunlight can provide by the sun, so we don't have to use the sunlight simulator to hit the membrane. And so it is just use a little electricity. Yeah, thank you.
And we all go to the support this opinion. And we have already demoed the membrane can to do the seawater distillation. One day can produce the 60 liters pure waters. We just use the 40 centimeter squares. So maybe in the future, we can have the large scales and we can create the more pure waters. And I think this is better than the RO systems. Thank you.
All right, put your hands again for the magic membrane. Thank you so much. 谢谢. All right, those were the 4 teams from the professional category. 好的，社青组的4组呢都已经报告完毕了。And next we're going to move on to the teen category. Yes, 6 finalists from the teen category are going to take the stage. 那接下来呢，我们今天下午会有6组的青少年组的团队依序的上台简报。And the first one is from the Kangqiao International School. Yeah, we are going to welcome to the stage the Aqua Guardian. 那没错，那今天下午呢，我们青少年组的第1组要为各位邀请到的呢，就是这个康桥国际学校的 Aqua Guardian. So please join me in welcoming the Aqua Guardian. 掌声欢迎。
看你们谁要报告。
All right, the stage is yours, Aqua Guardian.
Hello, everyone. We are the Aqua Guardians, and today we'll be introducing our innovative solution for advancing Taiwan's water quality monitoring system. So this is our outline for today's presentation. So first, I'll be talking about the ocean pollution problem. So we believe all these ocean pollution stems from municipal sewages, industrial waste, agricultural wastewater, and also livestock wastewater. And this affects the biodiversity, and also it destroys the marine habitats. It also risks transmissions of several health diseases. Next, I'll be talking about the effects of inland pollution. So first of all, agriculture and livestock wastewater are rich in organic content and a lot of minerals. This causes eutrophication of the coastal seawater. And this hurts the coral reefs and also causes red tide, which harms all these marine habitats. And also, I'll be talking about the industrial wastewater, which contains heavy metals and other toxic compounds that these tidal movement of waves can actually disperse all these toxic materials. And this causes deadly effects to the marine wildlife.
In Taiwan's current monitoring system, the government regularly measures pH, oxygen levels, chlorophyll levels, soil pollutants, and heavy metals in order to assess fluctuations in oxygen and water quality. Data are manually collected and sent to a lab for analysis every 3 months. Furthermore, we noticed that Taiwan also has an AI water alarm network. With detection happening every minute, it distributes 400 devices to 13 cities and counties across Taiwan. Although there is already a comprehensive water alarm network, we believe the current solution possesses 2 main limitations. Number 1, it depends too much on the government, and number 2, there's a budget limitation due to high prices. To address these issues, we hope to encourage citizen participation to increase monitoring network. Specifically, we're targeting farmers, industrial workers, and organizations that have access to open water sources in order to improve the livelihoods of those depending on water.
To achieve a comprehensive database, we propose our device, the Aqua Guardian, a data collector that uses IoT to upload the data points measured every 5 minutes in real time. We have identified 2 goals and methods for data interpretation that are fairly easy to compute. First, the device will fuel smart governing by helping the government to check water-related policies' effectiveness. Also, the device will spawn on regional spikes that indicate water quality fluctuation. The current system focuses on expanding the amount of measurements, which makes it pretty expensive, like Aqua Guardian. Right now, we have 2 plans. Collaborating with By collaborating with the government, we hope that the government will be willing to subsidize the device, lowering its cost and making AquaGuardian the desirable choice, which also allows larger deployment. The second plan is to commercialize the product. With the device's cheaper price, citizen participation is more scalable. We are targeting farmers, fish farm owners, and industry owners as our stakeholders. Citizen participation in the current system is limited to reporting ocean debris or marine wildlife sightings. We believe there are potentials for these customers to assist the government in monitoring harmful activities. Also, this cheap and automated device allows long-term data collection with minimal human labor, which elevates the incentive for citizens to participate.
Okay, so then who are we targeting in our proposal? So we see that farming and livestock raising industries are very popular in Taiwan, where we believe there is a need for close monitoring for those industries. And furthermore, we believe our device and our proposal will be able to track the current progress of improving water quality. So next, moving on to the design and geometry of our device. So here we aim to fit the 6 following measurements, sensors into our device. And the materials that we chose is polymer resin because it exhibits a wide range of strength, chemical, and environmental resistance properties. But more importantly, it is also used in 3D printing technology, where we believe we will be able to achieve fast fabrication and production of our device. And this is the outer appearance of our device, where we aim to use solar panel to sustain the functionality of our device. And next, moving on to the justifications of why we are choosing those 6 following measurements. And firstly, turbidity. So turbidity measures the clarity of the water body. So today, if the turbidity is high, it means that there's more inorganic and organic matter suspended in the water body, which we will be able to detect any physical changes of the water, such, for example, erosion. And second, dissolved oxygen levels. It is like a prominent measurement taken by government organizations around the world, where it tells whether this water is suitable for organisms to live. And thirdly, temperature, as it seems like a basic measurement, but in fact, it is really crucial because it conveys important messages. For example, the biogeochemical reaction rates of the water, which might induce excessive growth of certain organisms, such as algae, which might deprive the nutrients in the environment.
Fourth, pH is also an important measure because many aquatic organisms rely on certain pH levels or pH ranges within the water body to survive in the first place. Also, extreme pH levels may also inhibit enzyme activity, and by measuring pH, we can also identify potential chemical pollutions. Fifth, total dissolved solid and conductivity is also pretty important because it helps us identify the chemical makeup of water by indicating the presence of certain ions. Finally, oxidation reduction potential provides us an easy way to understand the sanitation of water bodies as well. Here is the budget allocation for the material cost for our prototype. We estimate that it will take at least 45,000 new Taiwanese dollar for us to develop the first prototype. But when we scale up the system, we believe that we can significantly drop down the price per unit to less than $10,000 per unit.
We plan to implement AquaGuardian both offshore and inland. For offshore applications, it can be attached to existing establishments such as wind farms. For inland application, AquaGuardian can be deployed in fish ponds, farms, and near factories. It is crucial to monitor water quality inland because these are the places where ocean pollution begins. Unlike current strategies, AquaGuardian is commercialized and low cost, which increases its coverage across Taiwan. AquaGuardian collects real-time data, which can be uploaded into a central database where the data can then be processed and integrated with current monitoring systems. Although AquaGuardian measures similar water quality parameters as current systems, its key benefit is that it's highly accessible, allowing local citizens and businesses to help safeguard our oceans.
We hope to involve 500 businesses and farms to provide a comprehensive network that tells us about Taiwan's water quality. When AquaGuardian's data is uploaded to existing databases such as iOcean and Taiwan AI Alert Network, it can be labeled as citizen science data, so it can be separated from professional data when necessary. This data collected by AquaGuardian can be used to find out average trends or to pinpoint collection points where the pollution levels are above regulations. We use soil analysis to evaluate the future outlook. Strengths of AquaGuardian include its cost efficiency and accessibility, providing opportunities for various applications. We aspire to collaborate with the government and academic institutions to further reduce the price and improve accuracy.
AquaGuardian is a network of automated guardians which collects water quality data, pinpointing pollution from their root sources. AquaGuardian will achieve increased coverage of data collection, and the data is comprehensive. And most importantly, it will allow citizens to participate into the data collection to form an ecosystem monitoring system. By monitoring our rivers, we will protect our seas. We are the AquaGuardians. Thank you.
Thank you to the AquaGuardians. Thank you. And now for the questions, Dr. Fan.
Okay. I think your presentation is excellent. You shows the teamwork. So everyone plays an important role, and the balance of the boys and girls and work as a real team. But for the content, I'm curious because you talk about pollution, but the major pollution usually is too much nutrient. So you measure the 6 parameters, but which one you think can show the highly correlation with nutrient, especially high nutrient cause the eutrophication, then cause the water quality degraded much? That's the first question. The second question is where will be the first place you trying to deploy these sensors? For example, where is the highly polluted and with high value ecological resources? Maybe like in northern Taiwan might be Ma'ao. Ma'ao, the coral reef degraded and a lot of pollution there. Okay, or Xiaoliuqiu is also another case. So where you trying to deploy the first sensors, and what's the reason you choose there? Okay, thank you.
Professor Ke?
Thanks for your presentation. I totally agree that Professor Fan say your presentation is so excellent. And also, I'm very happy we have so many young people who care about Taiwanese water. But I still have the question for you. So the first question is, after your presentation, I also wondering the most important thing. The most important thing is you want to promote the device or the network, because I think this is the two big issue, but you actually put together, but both of them are very hard. So which one do you think it will be the first one? And the second and the third question is like, I know you actually say the proposal like the device, and you say you may put some sensor in your device, and how big is it, and how about the price? Did you have any idea? And also, actually for those kind of the measurement, we have currently actually have the different data logger to record and monitor the nutrient or the other parameters, but it's not easy to put them together. So have you ever read about the information about that? And how did you think about that? Thank you.
Professor Liu?
Okay, I guess you're aware that currently the government already has a monitoring system, but you proposing to install another one. So what's the difference between your system and the government system? And you also come up with some number. You say that each device is going to cost 45,000. I wonder if you do the cost survey, because this is not a number that I'm familiar with, because I guess in Jiayi County, they last month they installed a new one. That one costs 800,000. So it's about 20 times more expensive than yours. So I wonder, how did you do the cost survey and if your number is correct? And also, this real-time system is gonna generate a lot of data, and someone need to analyze this data. And the current problem that the government faces is that there's too much data. If you don't analyze the data, make them into information, relevant or useful information. Otherwise, data is too much data without any analysis. It's gonna be garbage. So, who's gonna do the data analysis?
Professor Chen.
Good presentation, and also I'm very happy to see all the young people are engaged in this kind of work. Okay, and here I have two minor questions. The first one is that it seems to me that your job is going to design a device with sensors, right? With sensors to measure like turbidity, temperature, conductivity, etc. But I wonder, have you ever checked the feasibility of making such a device with so many sensors, okay, with so many sensors, all content in a single maybe box with the manufacturers, okay? Because this is just only a concept, but I don't know if have you ever checked with the manufacturers to create or to make such a device with so many sensors, okay? And also, how much, I mean, just as Professor Kerr asked, how much this device would be, and is it portable? I mean, because these attributes will decide whether this device will have a market advantage or reach the general public. Okay, this is the first question, and the second question is that I wonder when the device collected all the data and how you relate or how you transmit this data collected by all the general public to the central database. Have you ever thought of this kind of the issue? Thank you.
Professor Zhang.
Okay, good presentation and good teamwork. I just echo the Dr. Ko's comment. Device or the process to kind of participation of citizen science. Okay, so if you are focusing on the device, you need to explain more about the reliability and maintenance and also validity. Okay, and if you are focusing on the participation, then you need to elaborate the mechanism. The monitoring the data doesn't mean it can get the whole picture of the pollution. So you need to elaborate the whole process. So it depends on what you are focusing on. Okay, yeah, go ahead.
All right, you have 30 seconds. Yeah, quickly, gather around. Please answer the questions. Your 5 minutes start now.
Okay, so first to differentiate between the government system and our system, we believe that our system provides a more comprehensive overlook of the overall monitoring throughout Taiwan because we involve citizen participation. So this is the primary difference from the government because we believe that the current government system is too reliant on the government's budget and we want to involve more people within. And also, you mentioned about the price. The 45,000 new Chinese dollar, that is just for the prototype to be developed. We believe that when we do not need to try out all these many printing the circuit board, we believe that we can significantly drop down the price per unit. And since that the government has more emphasis on precision, we do not need the device to be that precise. We believe that the price can be less than what the government currently has. So by significantly drop down the price, we hope to involve more people like the farm owners or industry owners within the water quality monitoring. And also lastly, on the point on how we will compute the data, since that our data is probably less precise as compared to what the government is currently having, we believe that we can just look for regional spikes, or we can have we can look for the average trend of how the data is looking. These are all points that are fairly easy to compute, and we believe that we will be able to achieve this fairly easy by taking the average of data and seeking the general trend of how the data progresses according to government policy.
Okay. To add on to how we're going to process and display the data, by computing it into an average trend, we want to be able to organize all of this data in this method. And although it will not be as it's not as professional as the data collected by the government, our main goal is to have the citizen involvement in producing this data and to be aware that we are monitoring our bodies of water in Taiwan. So the main purpose is to allow citizens to be aware of this system and to also participate.
Okay, so about where will we conduct our first test? The place we're thinking of is Bitan, because our school is located in Xindian, and we have been training. We've trained to swim over the Salmon Lake and at Bitan, and we found out that the water is very dirty, and that's because of the factories are polluting wastewater into Bitan, and then so for our prototype test, we're aiming to go there. But after all, our device will be targeting farmers and industrial workers and owners to widen the data collection. Thank you.
Thank you, Professor Chen, for your question. About the point of feasibility, we believe that the government already has a similar solution, and so such a similar approach is already proven to be feasible. Furthermore, it's simply an add-on to the current solution, so it's not a replacement of the of what the government already has. Thank you.
Thank you for Professor Zhang's comments. So you talked about how the maintenance could be a problem, but like currently, government already has several devices, and we could implement their maintenance strategies on our devices. And also, our device would probably require less time to maintain since it's low cost and it doesn't have these high precision measurements, but it also can collect data that uploads to the AI Taiwan Water Quality Monitoring Network. Right, thank you.
Also responding to the second question from Mr. Chen and Ms. Chen about how we upload our data. I think we made it clear from our animation where we collect the data from the local devices and upload through IoT and Wi-Fi to a central database online where citizens or government officials can collect and observe those data. Yeah, I think that is the mechanism of our device. Yeah.
Also, to answer the question of how are we going to squeeze all the sensors in one box, I think the current system is already using a similar technology to squeeze all the precise sensors in one small box to measure to take all the measurement it wants. So I think this is not a big issue for our device.
All right, so thank you once again to Aqua Guardians from the Kangqiao International School. Thank you so much. Wow, that was very impressive, not only for the presentation, but also for the QA. They miraculously managed to make everybody to answer some parts of the questions. Wow, very good. Okay, we move on to the second team in the team category. This will be a joint team from the National Zhudong Senior High, Keelung Municipal Anle Senior High, and Taipei Municipal Huajiang Senior High. 那接下来呢，我们要邀请到台上分享成果的是竹东高中、安乐高中、华江高中的组合。OK， 让我们欢迎 安安，刚刚好像有什么东西滑进去了，我里面还不错。Okay? Yeah. Go up to the stage. Let's welcome them.
Okay. Hi. Hey, last visit to the mall was the best. Yeah, Mao is such an amazing place. I enjoy scuba diving there. Yeah, me too. Hey, do you still remember the sea women and men there? They are so cool. Yeah, I feel sorry for them. There aren't many visitors and there is serious ocean pollution.
That's what we're talking about.
Oh, hi. We're just talking about some ideas to help Mao.
Oh, you mean the C7 in northeastern Taiwan?
Yeah, there are a lot of problems such as water pollution and population decrease. People are leaving this place in large groups. Oh, I know. We can create some activities for people visiting Mao.
That's an interesting idea.
I know, right? Yeah, let's make a plan and share our idea with the general public. Good idea. We can save the ocean together.
And here's our proposal of Mao Sataumi. This is the outline of our proposal, and these are contents we'll go through. Last summer vacation, we joined an activity and we experienced the culture of Mao community. During these days, we discovered several problems such as ocean pollution and a lack of resources. We noticed that actually there are several places in Taiwan facing the same problem. Ocean pollution is the most serious and primary problem here. We hope we can figure out the best solution and maximize its effect to the other places in Taiwan.
Do you know what Sato Umi is? When it comes to Ma'ao, we need to understand the concept of Sato Umi. There are three important elements of Sato Umi, and they have great influence on each other. One of the elements is humans' well-being. Another is sustainable ecosystem. And the other is the prosperity of fishery. Based on this concept, we can not only use marine resources wisely, but also coexist with nature in the coastal ecosystem.
Now, let me introduce Ma'ao Fishing Harbor to you guys. Ma'ao Fishing Harbor is an old and small seaside village in northeastern Taiwan, and it's reported that its population is about 900 people. But in fact, there's only 300 people living there, and it's mainly elders or middle-agers. And visitors make living from fishing. And the seawoman culture is that seawomen and men collect seafood like gelatin without any oxygen. So there are four main problems in Ma'ao. First one is ocean pollution. There are two kinds of ocean pollution. One is human-made pollutions, such as restaurant releases oil waste to the ocean and tourist litters. The other source is marine debris. Next, the society problem are declining birth rates and aging. Like I mentioned before, there's only 300 people living in Ma'ao. Moving on, the number of the tourists are decreasing, which leads to the decline of the economy. Last but not least, the seawoman culture is declining too because of aging, and elders who make living from fishing usually tell their kids not to do the job because they're sporty in the job, dirty, dangerous, difficulty, and distance. As we can see, these are the problems in Ma'ao that we need to solve. So after talking about the problems in Ma'ao, are there any solutions?
We mentioned that there are a lot of problems in Ma'ao, and for the environment problem, we can create abalone experiment. And for the cultural problem, we hope to cooperate with artists and combine local culture with artworks. For the economic problem, we can make travel plans and share on blog. And for the society problem, we hope the local government can offer a job opportunity to local youngers and increase the tourism.
This is the abalone container that we usually see in some harbors. Abalones there might grow in the wild or were artificially bred. And the most special thing of those artificially bred abalones is that they grow the little abalones in the pool without any management. According to a research we read, the shell of abalone can purify the water. Thus, we designed an experiment to test whether it is true. We use chemical material to simulate the ocean pollution, and we test whether the abalone shell can decline the concentration of those pollution. Then we analyze the stats to make sure whether the abalone shell can purify the water and improve the ocean quality.
For cultural problem, we plan to cooperate with artists. Have you heard of Xinbin art? They are Geelong youth create more art and activities along the coast to make the Geelong harbor more beauty. Yanagi in 1998 said, high productivity and biodiversity in the coastal sea area with human interaction. And the ocean is the common property belonging to everyone. With the idea, we can make Mao better. For example, let artists create a song about sea women and introduce how to make gelatin soap.
We designed a tourist trip to improve the economy back when we were talking about when people were leaving and the tourists are declining. Because the jobs here are mostly diving, and the old people, they don't want the young people to do the same job they did. So we are thinking that maybe the young people can do the tourist kind of job. Also, we designed a menu. Well, if you want to travel, you have to have the food. So we designed a menu based on the local foods. And abalones, they're all homegrown there. They're very eco-friendly and sustainable. Okay. So we're approaching there, and now we're going to have a little say.
Ocean needs help. We heard a yelp. Let's break it down now.
Okay, the ocean is our planet-like support system, and it is in peril. I will no longer stand in idly as human activity to destroy this vital resource. Ocean is part of our nature. We need to do something to save it.
Ocean is our mother. Let us save the ocean.
We have the responsibility to save the ocean, and that's what we are doing now.
Our environment is getting worse and worse, and we need to spring into action. This is our responsibility.
To respect the power and the beauty of the ocean, we have to take action now.
Reduce, reuse, recycle. That's the staple of our generation. Thank you for listening.
Thank you so much. All right, and Dr. Fan?
Okay. I think this presentation for me is amazing. Okay. Now you had, I think you have several challenges. You need to reach your goal. First, you are come from Taiwanese school, so I'm wondering how each of you learned the English and made the English presentation so good. And second question is, you come from three high schools. How do you work together? And okay, what reason makes you three school students work as a team? And then for me, it's all I'm highly curious. How do you translate the Chinese title to English title? And what's the idea? You name this title, okay? Another, if someone donate 10,000, not 10,000, 100,000, or a local company or a local community want to support you, what's your plan? to use those money. Okay, thank you.
Okay, I also have I also feel that your presentation is have like the story, so it's very interesting. And also I like your slogan and as well as your commitment from each of you. So thanks for your patience. And wonderful thing is feel so happy is you have the very great scope for the whole idea and the whole solution for the Maoao village. However, so because you have this such great scope, so I feel that looks like you still lack of some focus. I don't know which part you really want to do because you mentioned about environment, society, economy, and culture. But though I feel that all of them are very important, but what I think is if now we want you to do something and we only have the limited money or the manpower, and which part do you think is the most important part that you should do? And so I think it's the quite important issue that I want you to think about it. And the second thing is for the environment, especially you use the abalone experiment. You think you will use the abalone to clean the water. However, have you ever eaten abalone? Yes, everyone like that. So if you eat that food, so did you really want use it to be like the something to clean water? And after that, can you still eat that, or you think the economic about the abalone will be decreased or something like that? Thank you.
Thank you, Professor Ke. Professor Liu.
You mentioned that you have a water pollution, ocean pollution problem, but which type of pollution are you talking about? Because there are several types of ocean pollution, and you seem to want to use the abalone to, clarify the ocean. So, can you tell us a little bit more about the problem of your ocean pollution? And then it seemed weird to me because you say you have decreasing tourists and you also have immigration problem because younger people moving out. That means you have less population. Doesn't less people mean less pollution? Can you pinpoint the source of your pollution because you have a decreasing number of population, and how come your pollution problem is increasing? Okay, and finally that for now you're probably the aging population, and you want to attract more people to come into your community. And can you explain a little bit more about how you're going to do that and how you're going to achieve that?
Professor Chen.
I have some question for you. You just mentioned that, in your presentation, propose several alternatives, try to rejuvenate Maoao, okay? And for example, like a travel plan or abalone culture. But I just wonder, have you ever talked about with the local people, is that, what they want? These people really want the travel plans or the abalone culture in order to rejuvenate their fishing village, okay? And maybe local people are accustomed to their non-original lifestyle, okay? So how you think that the proposal that now contained in your presentation is what they want, okay? And the second question is that we know that Maoao is like one of the example that face the all migration of young people, right? And also the ocean pollution. So given the proposal, the alternative that you have proposed, so I just want to ask you a question. You are young people, right? Are you willing to live there? Your presentation can persuade you to live there. Okay, you just answer me this question. Okay, and then the third one, Dr. Fans said that you translate your title into Chinese. Okay, I just want to know that the Chinese title, in my view, the title in Chinese cannot reflect the core elements of your presentation. So, what would be the next or the alternative title in English? Can you give me now? Okay, thank you.
Professor Zhang.
I appreciate that you raised the concept of the Satoumi, and it's really a great concept. And also you, explained that's the human being at the center and the influence that impacts to environment. That's great. Okay, and just two questions for you. The first one, have you been to Ma'ao? Okay, okay, sure. And have you seen the sea woman? Okay, that because you mentioned about the problem of the culture, the sea woman is the number is decreasing, right? But you offer the solution to cooperate with the artists. So what's the solution response to the problem? How would you explain this? Okay, yeah.
All right, now you have 30 seconds. Time's up. Okay, please. Your 5 minutes start now.
To talk about how we learned our English from the first question. Well, I'm mixed race, so I didn't.
Okay. I learn English from kindergarten, but because I'm lazy, so my English is not as good as them.
So I'm gonna end this. So how we cooperate, we open up meet and we and we practice a lot.
I learn English from the English books because we need to test. So I am very hardworking to learn English.
When I went back to home, I started to watch YouTube videos. So I think I learned English from YouTube videos. 要讲吗？
I learn English because my school is some Cornell Academy from Hsinchu. So I learn English when I'm very, very small. So that's how, yeah, with her.
For Professor Liu, you talk about the ocean pollution and what kind of ocean pollution is it? I think we did the chemical material experiment, and we think the pollution is the chemical. And for the professor funds donate 10,000. 100 million plan. We think we can first do some solutions we talk about, and then we can think of more solutions and to make Mao a better place.
Okay. Okay, I'm gonna to respond the title. Yeah, how to translate. This is my idea. The title is my idea because I think I want to let the title get more interesting, and I choose every school first name to name the title. But how to translate? I think I will translate that. Hey, have something sleep in. Yeah, yeah, yeah.
And about the cooperating with the artists, it's all a part of the tourist plan. The most important part is to get the tourists back. If the economy is not flowing, the young people won't come back. So yeah, we try to get more basically advertisement. And I think we went there, so all the local people, they really want to see this place kind of go back to what it was and have the economy live again.
Oh, we have went to Mao and we asked the local people what they want, but some of them think that they don't want their kids to do sea woman or sea woman, but some of them think that we have to how do I say that? We have to do this. We have to combine arts. We have to let everyone know the culture of Mao and sustain it. Sustain it. Yes. Any questions more? No. No. Okay. Okay. And
respond Professor Liu. You asked what type of ocean pollution, right? I think is chemistry pollution. Yeah, so our experience is about the chemistry. Yeah, 那我们may I use Chinese? 呀，我们这个实验就是要做，就是将九孔置于一个容器中，然后在里面滴入硝酸银，九孔壳滴入硝酸银，然后再让它吸附氢离子之后，再加入硫化钠，然后让它用沉淀反应，然后来去量它的沉淀物的重量，然后看看它有没有减少。如果有减少的话，就是代表它会吸附这个化学粒子。
志勋这一段你要翻成英文，因为我们有国际团队在线上看。
But that is our hypothesis, so
just kidding.
Yeah,
it's okay. All right. Okay. Thank you so much. Thank you again. Thank you for making this session so much fun for us. Thank you. All right. Okay, everybody, we're going to take a coffee break from here, and we'll be back by 10 after 3 o'clock. Okay? We'll be back by 3:10. Let's have a break, and we have refreshments ready on the second floor. Okay, the same place you had your lunch. Thank you, and we'll be back by 3:10. 那接下来呢是中场休息时间，我们在大家用午餐的地方呢有准备茶点，都欢迎各位贵宾呢可以自行取用。等一下3点10分继续回到会场。 Begin the next session in 3 minutes. The next session in 3 minutes. Thank you. 大家，我们下个场次呢，再过3分钟，再过3分钟之后正式开始，谢谢。All right, everyone, please take your seats. We're going to begin in 1 minute. Thank you. 请大家就坐哦，我们再过1分钟之后就要正式开始了，谢谢。Okay, everyone, welcome back. And we have 4 more teams to go this afternoon. And next, we're going to welcome the ocean detector from the Kangqiao International School. So please give them a big round of applause. 接下来呢，我们要有请康桥国际学校的 ocean detector 上台为我们简报，掌声欢迎。
Hello everyone, we're the Ocean Detector. Protect the ocean for today and tomorrow. My name is Noya.
My name is Sydney. So we discovered the problem of the majority of the marine garbage produced by people in their daily life go into the ocean. It's not only letting the ocean get polluted, but also letting the ocean animal facing extinction.
We will protect the ocean for today and tomorrow. The word today stands for currently sharing our picture book with the children, and they will now avoid leaving trash along the seashore and be more likely to pick up the trash along the seashores. And the word tomorrow stands for influencing the children in long term, that they will be likely to be aware of ocean environmental issues in the future as they grow up.
So for our product, it'll be specialized for the kids, which is it'll be provided in 3D with variety of drawing and picture, letting their learning process more interesting. And moreover, easy words and composition will be used in the book, which be suitable for a wider age range of kids. And the book will be provided in bilingual, which is being used, provide an English version and Chinese version.
The market need of children's storybooks continue to increase as parents are more eager to buy storybooks for kids as they see pre-education as more important. So the growth of 3D picture book is especially significant in the children's book market. According to books.com, 3 of the top 10 storybooks for kids are 3D storybooks. And Real Publishing published data that there are over 1 million 3D storybooks sold in 2019, and it is predicted to continue growth in the future.
So this is our SWOT analysis, which, according to our design, we think our stress will be suitable for a bigger age range of kids, and having a chance to collaborate with the professionals, we think that our book could be more informative than the book that have been produced in the markets already, and as the book is being provided in bilingual, it will increase the probability of the chance that our target customer will purchase the books due to people learn in different language, and by providing 2 languages will be more suitable for the target customer. And the weaknesses that we think we have is, as a new business, we do not have the customer base, and because we're the new businesses, so we have limited fund, and we can't really produce a large amount at first, and the not professional drawing painting skill might be a disadvantage for us.
However, we still have some opportunities in the market, as our product, the storybook, is continuing as more educational that we cooperate with professionals. It can attract more educational institutions to purchase our product. But there are still threats in our market too, because there are a lot of competitors in the market, and we're lacking capital. It may make us less competitive among the competitors. Next is the marketing position. We briefly summarized some 3D picture books on the topic of marine and ocean and the top sellings of books.com. And we organized this into this chart. And we set our product as considering more informing and low price among the markets.
So in the future, we're looking to collaborate with some organization. In order to carry on with this project, so we select Marine Biology. Marine Biology is an organization that is currently supporting marine projects that have been produced by high school students.
Next is the TAM Samsung. TAM stands for the total available market, SAM stands for the service available market, and SOM stands for the service obtainable market. So our target customer here presented is the educational institution. The educational institution of the total available market is that as the number of preschool and educational institutions in Taiwan. And the service obtainable market is narrowed down into the private preschool and educational institutions in New Taipei City, Kaohsiung City, and Taichung City. The next target customer is the parents. So the TAM Samsung for TAM, the total available market is set for the family with children, the amount of family with children in Taiwan. And the service obtainable market is 30% of our service available market, which the service available market is the number of family that has children with an annual income over $1 million.
So that is our target customer segment that have been divided into 2, which is this one is the parents, and the following trade is what is expected for this target customer. And another one is the educational institution, which serve the children around the age of 3 to 12 years old. And the following trade is what we have expected for the educational institutes.
So, as children and family made a big part of the beach visitors, we expect them to have some behavioral change after reading our storybook. We expect children to avoid to leave trash among the seashores and pick up the trashes among the seashores. And as they are young age readers of us, we expect parents to read along with them. So this can also at the same time increase awareness of ocean environments among adults.
So the key resources have been divided into 3, which is the capital, outsourcer, and the raw material.
For promotions, we are likely to promote our products by hosting events. We will host events such as cleaning beach with parents and children. So this can promote our product and at the same time protect the ocean environments by picking up the trash among the seashores. We will also host other small promotion events such as making some sweets with marine animal pattern to attract children's attention and setting up ads on social medias and apps that are widely used.
So that is our economic chart of startup investment, and all the money is in New Taiwan dollar.
This is our economics of 1 unit. So our picture book price is set as $599, and this includes the average cost of per picture book and average profit per picture book.
That is our break-even chart, and break-even chart is letting us to be able to predict when is it going to start making the profit, which will making the profits on the number 280 book that we sell.
This is our monthly sales projection. According to our research, children's storybook are mostly sold in times, such as their summer vacation time and winter vacation time. So we predict July and August will have the highest sale, as we will host the most promotional events in July and August. And in winter time, there will be less sales because we won't host a lot of promotional events in winter due to weather conditions.
And that is our yearly income statement, which is on the basis of selling 555 books a year, will make a profit around 160,000 at the first year.
This is our ROS and ROI. Thank you, everyone.
Thank you so much. All right. Stefan, for questions.
Okay. Very interesting presentation. So you mentioned the 3D story books right now is more and more popular. So I'm wondering, is any the 3D story books talking about ocean issue, and you think is the best learning model for you? Then which the 3D books you recommended? That's first one. Then what will be the topic and your the topic and the title of the 3D books your team would like to make? Thank you.
Professor Ke?
Yeah, thanks for your presentation, and I like your idea to link into the current product for the 3D books. So I think the same. So not only for do you have the model, but also I want. Can you share us what kinds of the content do you expand in your marine related 3D book? And also, I'm also interested to. I also want to ask you. Can you give us the name of the title about your book? And also, I have the question because you already have this kind of the idea, and you mentioned about the 3D book. So, have you ever designed or done an ocean related 3D book directly? You can answer later.
Professor Liu?
Okay, I want to ask you, is this book story based or just pure picture? And then you say your audience, your target audience is age 3 to 12. That's a big range. 3 years old, they probably only see picture, but 12, if 12 years old, maybe they want to see comic book. So there's a big range of your target. And then I wonder what the name of your team, Ocean Detector. I wonder what it means, because when I see the name, I thought you're gonna detect something, but your final product come up with a picture book. So is there any relationship between the team name and your product?
Professor Chen?
I would like to know that have you ever done the survey on the market of 3D picture books? Why I ask this question? Because that I know, in my opinion, children may not like a 3D picture compared to other learning tools. For example, like the board games or other tools to learn something. So how about the market? How about the market of 3D pictures currently? Okay. And the second question is that you just mentioned the marine garbage or marine debris problems, right? So could you specify the be more specific on the content or the topic that you are going to present in this book, okay, in this 3D book? And also you mentioned that if you want to present this this product or 3D book, you just mentioned that there are weaknesses and also there are some strengths, right? And for example, you just mentioned that there's a lot of the same products on the market, right? And so how you solve these weaknesses or strengths? Can you just give me some examples of how you to solve this weakness or strengths such that your product can have a market advantage? Thank you.
Professor Zhang?
Okay, picture books are very popular and also it's a very powerful educational tool. So that's a good idea, okay? Two questions for you. The first one, so what are your roles in this project? Are you writing the book or are you just a salesman to promote the idea, to look for some partners? So that's the first question. And the second question is, you mentioned about the expected behavioral change. Okay. Yeah, after reading the books, right? Okay. Then what's the hopes? Then they can reading the books, then they change their behaviors. So what the cause? It's because the book, because of reading, or because of the content of the books. Just try to elaborate what's the cause to their environmental behavior change. Okay, good.
All right, 30 seconds before you answer the questions. Right now, you have 5 minutes.
So our 3D storybook learning module is actually presented in the previous slides. Previous slides about the
我们可以再帮他们把简报放出来吗 ？Ocean detector.
And so I'll first name our storybook. Our storybook is mentioned in the first page of our presentation, but we didn't actually speak it out. The book name is here, 沙滩上的小动物，小生物怎么了? So we're mainly focusing on the topic of sea marine animals, and we'll be most likely to focus on sea turtles and the garbage that they're more likely to eat some garbage and some plastic bottles on the seashore. And so the 儿童趣味揭秘翻翻书 is our learning module of our product because it's more informing, but we will likely to make our book more entertaining than this book because we will be more likely to attract some smaller age readers. And so we actually didn't work on similar projects before, but we will likely to try on this project because we think that further generations can really impact the further conservation of our ocean environment. And our group name of the ocean detector, it really means that we will like to detect the current and future influence that we can make on the ocean environment. And we will likely to target the children to make further impacts.
Okay, so for the role in the book, I'm making the book will be the one who create the content, and And about the drawing part, we might have to go and find someone because we have tried before and it doesn't come out really good. So we don't really provide the photos on our slides. And moreover, we have thought about like what will be the cost about the kids that have read through the books. I think when we're young, we have learned through a lot of stuff. And if the parents are taking them through something meaningful and they will wanted to copy through their parents. So we hope by going through the context and like having know how they can help the ocean, but in their current age, such as just be themselves, like when they hang out on the beach and they know how to take the trash away, that'll have a small impact on Earth already. So I think that is the cost through that. And about the survey on a 3D picture book, we didn't really do that before, but as what I think,
we believe that because as we cooperate with these judges and the organizations, we're likely to make our product special than other products in the market because they don't have a chance to cooperate with such professionals. So we think that our product can be special in the market and are more likely to attract customers. Thank you.
Okay, thank you very much to the ocean detector. Thank you so much. And our next team is also from the Kangqiao International School. That is the Weddell Sea. And the team is going to help us explore Sea Fortune. OK， 那接下来呢，我们下面一组为大家邀请到的一样是来自于康桥国际学校威德尔海，题目是海洋财富。OK，so please welcome the members of the team， 掌声欢迎。
在讲的时候都要回去前面把它放在上一页就好，然后再继续往后。
上一页是这个。
上一页对对。
哦，
谢谢。
没事。Okay, so good afternoon, ladies and gentlemen, judges, participants, and our online audiences. My name is Kelly, and standing beside me are my partner, Vera and Sylvia. So today we'll be presenting our project, which is called the Sea Fortune, and this is a visionary project that aims to safeguard the ocean.
Yeah. So the problem that we're trying to solve is that there's so many trashes in the ocean. So our solution to it is that we try to use those recycled wastes and turn it into a entertainment board game for students and educators. So all those people can raise their awareness of their impacts to the environment.
Our firm Sea Fortune is a for-profit social enterprise organization that seeks to find method and strategies to solve the ocean pollution by recycling the ocean debris and turning it into an entertainment board game. And we will be donating our board game to the Environmental Association and the as well as an individual with the lower incomes.
And let's go to the consumer base. We have two groups. One is student and the other one is the educational industry, and both of them are for all genders and all social classes. We're not excluding anyone. And for the age of the students, it will be 8 or above, and the industry will be 21 or above. And the purpose for both of them are entertaining. We hope that they can have fun when they're playing the game and also to reduce the pollution.
Okay, so here comes to the product design. So in this section, you'll be able to know more about our board game. So the inspiration of our board game is from an existing game called Cluedo. And with similar game procedures, we then came up with a new version, which is called the Corporates with the ocean theme. So the objective of this game is to find out who's the culprits that polluted the ocean, which players will also need to identify the where, who, and what's card in the envelope. It would be good if you could
calls for like 3 to 6 players to play this game, and the first person who guesses the right what, who, and where cards in the envelope wins the game. So here's the product design of our cards, and we selected 6 beautiful and well-known beaches in Taiwan, and all these card games were illustrated by Olivia. So there's a unique part of our game is that on each card there's a few sentences of the ocean facts. So while the players were playing, they could learn more about the ocean. Next, we have the what's card. So for all these cards, we'll be collecting the actual ocean waste to place inside our board game for the model. And here are the top 10 ocean waste in the world. Next, we have the who's card. So we also created 5 other characters for the players to choose from. Okay, so lastly, we have the opportunity cards. So while playing the game, each player may have the chances to pick up one of those cards, and those were for players to have more clues to win the game.
And let's go to the SWOT analysis. The strength of our product would be that it is entertainment based, and we use WASES to create this whole board game. And the opportunity is that we will collab with the ocean conservation organizations. And next, let's go to the aspiration is that we change those WASES into a new form. And the result is that we hope everyone will have fun when they're playing it, and we can reform those WASES into a meaningful purpose. And next one would be the cost. As you can see in slides, there are the human resources required listed, and the material cost would be $13 in total. So for the competitor analysis, our main competitor would be Hasbro and Mattel, and both of them are really, really well-known companies. And so our main thing that can win over them is that our price is relatively cheaper than them. It's like $10. You can buy a meal with $10. So obviously you want to choose our product. And so the advantage is that we're the first mover. We're some of the first people to came up with this idea and actually make a move on it. And the advantage for the other two companies is that they have so many different other variety of goods. And the disadvantage is that they have poor working conditions, and for ours is that we might have potential copyrights problem.
As you can see, this is our firm's strategic and industry position, which we are located in the second quadrant, where the price is relatively low and has a high educational value. Next, moving on to our business model. The following are the key activities: product design, strategic marketing, promotion, negotiating with the manufacturers and distributors, and also engaging with the ocean marine conservation and programs and projects. Now, moving on to the key resources. The key resources include outsourcing other company to manufacture our board game, and managing our human resources. And we also need some cash to produce our products. Now, let's look at the key partners. We will be collaborating with the Project Blue 1095 initiative, which will be introduced by Kelly later on. And to be able to make our board game from offline to online, it requires us to collaborate with the Steam company. And lastly, looking at the cost structure, the fixed cost is the operating cost, and the variable cost is the production cost.
Okay, so as for value proposition, we are hoping to raise environmental awareness through among students, and also we hope to create an environmental friendly society. And for customer segmentation, as mentioned previously, we're mainly targeting on students and educators from all social classes. And in terms of the channels, we'll be selling our products through our official website and retailers and e-commerce such as bookstore, PC Home and Shopee. And to build a bond with our customers, we'll be promoting our brand through social media advertising. And we'll also be setting up some customers help desk to support our customers. Additionally, we'll also be sending out customer satisfaction survey to ensure our product meets the customer expectation. And the last part of the business model is the revenue stream. So it will be largely based on the quantity of board games sold. So here's the company overview of our key partners, which is called the Project Blue 1095 Initiative. And this is a Taiwanese domestic project that calls on businesses and non-governmental organizations to pick up ocean wastes and to clean the beaches. So their aim is saying similar to us is to recycle all that materials and make it into a environmental friendly product.
And I'm pretty sure all of us have a mobile phone. And so we might use the mobile phone to talk with our friends or play games. So we have this an inspiration that we should change the game offline to online so everyone can still have connection via the internet or offline. And if you have any question, you may ask us after the presentation. Thank you.
Thank you so much to the YLC. And now for the questions, Dr. Fan.
I think the content is very interesting. And my question is, there are 6 sites in your board game. So why you choose these 6 sites? Is there any other place if you replaced might be even more interesting? And is any? And then second is, do you have a prototype for your board game? And if someone, if you got a seed funding, you can produce the prototype your board game. And what's the timeline? We can see the product. And finally, it's a board game. Why do you think people play the game and change their behavior and became a real action to protect our ocean?
Professor Ke?
Okay, thanks for your presentation. I like this idea, especially you will use recycling materials to make the board game. But linking to this, because you say you always emphasize that the price will be very low. It's just only $10. However, you know, when you use the recycled material, always the cost is higher. So I don't think, especially if you want to use the recycled material from ocean, so it shouldn't be so cheap. So this is the first one. And the second question is, I remember you proposed for the 2 versions. One is the educational, the very young, for the young children. Another one is for the adult. And you set up for the 21, I remember. Why is the age of the 21 for the industrial version? And the final question is, you already decided your board game, including where, what, who, and opportunity cards. However, I still cannot know who will be the winner. So the result. So what kind of the activity finally will be the winner? So can you also explain more for us? Then we can know how we can learn from this future board game or what you want to achieve.
Professor Liu?
Okay, I would say I love board game, but I think for board game, the success of a board game is that you will come back and play it repeatedly. So I'm not sure if you have experienced that you download an app game and then you delete it right away because it's not fun at all. So I want to ask you, can you rate your board game from 1 to 10? 1 is not funny to play with, and 10 is I will play it every day. So what do you think of your board game? And then the next question is, you have the marine debris on your car because you say it's going to be educational. If you're going to come up with other idea, what's the picture that you're going to show on your car? if not marine debris? Or is there any other idea that you want to show on the car? Okay.
Professor Chen?
Here, I would like to ask you some question. The first one that I would like to know that what's the funny point in your game that can attract people to play this game? Okay, you just specify what's the most funny part that can attract people to play this game. And the second is that you have done the competitor analysis. I think it's very fun. Okay, it's very interesting, and you did try to survey the market acceptance of this product. But I just wonder, do you are there other similar board games made in Taiwan? Not because it just mentioned, it just referred to the products in the made from by foreign countries. Okay, so I would just like to know that have you ever done any surveys on the market of the board games and the features the same issue, maybe any ocean issues, and also have the market advantage. Yeah, and so how about that the market competitiveness of your product compared to the products now already at the market? Okay, thank you.
Professor Zhang?
Okay, yeah, I really appreciate the cars you designed, where cars, what and who look like very beautiful and yeah, well designed. This, yeah, great. Okay, and just one question. You mentioned about the board game is prices fair to low, but with the higher educational purpose, right? And just give me example, what kind of educational purpose have you infused into the board game? Just give me one, or yeah, just one. What are you going to teach, and how you infuse into the process of the board game? Okay.
All right, so now you will have 30 seconds.
Yeah, that's it.
Okay, 5 minutes.
So the reason why we choose the sixth place is because we actually did some research on some Taiwanese beaches. So those 6 places are like the dirtiest beaches in Taiwan. So that's why we're picking those to be in the worst cars. And about when can we see the product? So I think this to construct our board game, it's quite time consuming because we still need to like go to the beaches and collecting all those wasted and then contain all those wasted into our board game. So I think it will probably takes about like 3 to 4 months duration to like done the whole process. But yeah, basically. And so we think like throughout playing this board game, like we hoped youngs can raise their awareness through this, because I know a lot of people they're unaware about the ocean issue. So through this board game, I hope that our players can like feel like they can become like an ocean lover, and maybe sometime if they see some activities that are related to ocean, they can like kind of they would like to participate in the future or something like that.
And for our second question, is the price too low?
I don't think so. It's US dollars. It's not Taiwan dollars, so no. For the age, why is it 21? Because average educators are around that age, like in their 20s or above. That's why. And the third one, how do we know who's the winner? Kelly will explain that. Thank you.
Okay, so we didn't have really time to explain like the game rules. So you have like 4 categories of the cards. So you'll only be using like the what, where, and who. So you will take like one of those cards. You will you will face all cards down and pick one card from each category, and then you place into an envelope. So for each round, each player will be like to make a assumption that which they assume, let's say, who and where and what the cards that's shown there. And the person at the right, if you have any of the cards that are mentioned, you have to reveal one of them to the person who's saying that, so that you can, so you're trying to like eliminate all the possibilities that are not in, like you're trying to eliminate like the cards that are not in the envelope.
So what are we trying to achieve? Let everyone know that sometimes they're not being nice to the ocean. For how fun is the game? 1 to 10. I'll say 7 because I'm not a smart person. I'm bad at playing these games. But it's pretty fun because like you can have the time to like hang out with your friends and then like finding who's the bad guy, and like it's kind of like you're lying to them, like you're not telling the truth, like, oh, I'm not going to tell you what's in my card. And the fourth one, what's the fun point in the game? I said it. And similar game in Taiwan, no. We search it and no. And how is it competitive to the games that are not existed? Our main target is for students and educators. So our marketing target is mostly like people are at school, and we're not really focusing on people that will like play it daily. It's more like playing at school, maybe during club time or something like that. And the last one, what purpose you infuse into the game? What purpose do we infuse the game? We try to put the facts. I think that's the main point of the whole game, is that we put the facts about the ocean wastes, like what humans do to the environment and all that. And then in the opportunity cards, there are 2 cards that is like you have to share the fun facts to each other, and then so we can share like different knowledge and then understand more about your impact to the environment. Yeah, that's it. Thank you.
Thank you.
All right, thank you once again to the LC. Thank you. Thank you once again. Next, we're going to have the people from ITC. Please come join us on the stage. All right. Next, we're going to have the team from the International Bilingual School at Tainan Science Park. 那接下来呢，我们要请到的是国立南科国际实验高级中学的 ITC, and they're going to talk about fish farming, healthy feed alternative. All right. So, come to the stage.
有人要讲，3个都会讲，3个都会讲，那我们最多就2次。然后你们讲，另外是你们如果在讲到说啊，回顾看你们之前的，看你们之前可能看上一句，要再去。
Okay, so ITC, now you have 10 minutes to present your ideas.
All right. Hi, we are ITC, and we are going to present you our proposal on a healthy fish feed alternative. Yeah, so we're from International Bilingual School at Tainan Science Park. This is Tony, I'm Jonathan, and this is Kanisha, and we're missing 2 teammates. So that's sad, but yeah. So this is basically an overview of what we're going to be talking about. We're going to talk about the scale of the issue, why we're doing this, our strategies, and what we ultimately plan to achieve and what we expect. Yes.
So the scales of and the issues of aquaculture in Taiwan. Basically, as an alternative to the traditional fishing, the fish farming industry has been starting to gain popularity, and it's now playing a major part in the aquatic industry. It holds about 350,000 employees and takes up 42,000 hectares of land in Taiwan. Basically, it's a better alternative to traditional fish farming because it reduces pollution, overfishing, and ghost fishing. And because of its gain in popularity, it is predicted to grow in the following years. Yeah. There are still some issues to fish farming, and the major one is the spread of diseases. Because the spread of diseases can increase, most fish farms are kept under heavy supervision, and a lot of antibiotics are used in them. Basically, how diseases can develop is if fish are under stress or the farms are not cleaned out regularly. And then if the fish escape their environment and enter a new one, the disease can spread to other ecosystems and also harm other communities. Excess fish feed in open water aquaculture can also increase eutrophication, which can damage the fish's health. Our motivations. So these are our motivations. One, we want to provide quality food for the fish to improve their health, which would also improve the health for humans because we consume them. And then the fish farms, if the fish are healthy, the fish farms will have a good source of fish, which will also help the economy and benefit everyone. And this is also to help prevent the spread of diseases into the ocean, just in case fish might escape into the ocean or the contaminated water might get released into the ocean. And then we also want to decrease the feeding of bread to the fish and instead use our alternative source, which is our idea of promoting beef or lactic acid. And this can improve the fish's health, and also it's better for the environment.
All right, so I'm going to be talking about our strategy and what we plan to do to solve all these problems with current agriculture. So this is before lactic acid bacteria. It is by no means a new bacteria to the world, but it is highly underestimated and not informed of. So basically, what it does is it produces a probiotic called dextran, and what this does is it causes multiple benefits in a fish. So to test the effectiveness of the bacteria, the Fisheries Research Institute, they did an experiment over a 2-month period, and after these 2 months, what they saw was in the experimental group, the experimental group's fish had an average larger mass. What this means is that there will be more biomass per fish farm, and what this will allow is less amount of open sea fishing, and so there will be less overfishing, less ghost fishing, and all those other issues. So another thing it does is it provides resistance and removes pathogens. So this means that bacteria will be absent in the fish, so they no longer can infect other fish, and also this decreases the need for the amount of feed, the amount of nutrients they need in the feed, because it also provides extra growth. So they don't need to excessively feed the fish, and this will allow. They don't need to excessively feed the fish, and then there will be less cases of eutrophication. So the reason why this product is so enticing to fish farmers and why you can't really argue against reject it is because it's only 0.5 NTD per kilogram extra. So and they also estimate that it's around 150,000 NTD per hectare in profit. So what we plan to use as a strategy is we plan to create a website to promote and display this website through QR codes on beaches, and this will allow people to learn about the effects of the before lactic acid bacteria, and so they stop or they gain awareness of this. And we also plan to start. We also plan field trips for
younger generations. So allow us to educate the younger generation. They can make this yogurt, take it to fish farms, and then after that, we can not only educate the children, we can also educate the fish farmers about this new feed alternative. So our ultimate goals are to promote the B4 lactic acid bacteria. So we want to let everyone know about it. We want to show that there are alternatives to current situations and that you can't just sit idly by and wait for something better to come along just without doing anything yourself. We also plan to decrease cases of eutrophication and runaway diseased fish that will infect other fish in the sea and ruin the environment. And I want to clarify that we're not mass producing this yogurt. It is by no means our product. So we are just trying to spread awareness and hope that the world becomes a better place. Yes.
All right, so the budget. All right, so the budget it totals up at an estimated about 61,000 NTD. The boards are about 1,500 each, and we want about 15 of them, and 100 NT each for the posters, also 15 each, and 5,000 NT for a strain, which only need 1 of, and 3,200 per trip, which we hopefully would have 10 of for those students that we talked about previously. All right, expected results. So well, there's a lot of expected results because first of all, economically, so it's a cheaper feed. So that would also raise up the GDP per capita for fish farms. And more importantly, as we have mentioned, these fish farms allow the fish to grow bigger and faster. So that makes like a better product for the farmers in general. Also, as well, since these fish will be healthier, they fetch a better price per fish. So that would grow up grow up the economy a lot more, and the growth of aquaculture industry. So hopefully we can start changing from open sea fishing to fish farms, which is a more environmentally beneficial way if everything goes as planned, of course. And more importantly, environmentally, so the health of the fish. The yogurt it's able to eliminate the pathogens that make the fish diseased. So now that we have healthier fish, it also decrease the cases of fish disease, like runaway fish that from fish farms that are diseased and then create offspring, which ruins the environment and then decreases biodiversity. So that would decrease the case. And then there's also harmless fish feed. So as we mentioned before, more eutrophication is harmless to the environment and also healthier for the fish. All right. So more importantly, as we have mentioned, we're not mass producing them. So our point is to promote this product because this yogurt thing it's a very new concept, and we're here to introduce the concept to the world to make sure it gets everywhere through our websites and our field trips for the students. So the students can tell their relatives and then spread this information throughout their family and to other people, all their friends and all their connections to spread this concept about the yogurt. Thank you.
Thank you very much. Now for the questions, Dr. Fan.
Okay. I think it sounds like you are marketing this bacteria. So because you comes from the science park, right? Did you do a preliminary experiment to test does the effect really exist when people capture fish? And is the effect species specific or it has a widely effect? Okay, then if you promote this product, but the users found it doesn't work and they sued you, what could you do? Thank you.
Okay, thanks for your presentation. And so I also have the question for why did you think why did you think about this kind of the probiotics, because there are so many kinds of the probiotics, and why did you choose the B4 lactic acid bacteria? Have you ever what is the beginning from your idea? This is the first question. And the second question is, did you find any people have used this kind of the bacteria to use on fish farming? Because I would assume there are so many fish farmers. So if this bacteria is so good, so there should be many people already use that. And the final question is, because you said that you use a yogurt as your example, but how do you know fish can digest? And this kind of the lactic acid bacteria can really make fish healthier or stronger, or they or a better taste. Thank you.
Thank you, Professor Ke. Professor Liu.
It seems to me you are promoting a probiotic. Do you know if this probiotic is under tentative experiment or they're already commercialized? And it seems to me it's a food supplement. If it is a food supplement, do you need to get government's license to sell it? And then you say you're not mass producing it. And my question is, who's gonna mass producing those products? And it seems to me you're gonna set up a website and promoting the use of this product. I think maybe you may as well promoting, environmental friendly practice for fish farming, because you're promoting a more friendly fish farming, which may maybe some energy saving device, or you can recycle the wastewater, or there's a lot of friendly, farming practice for agriculture. And yeah, that's my question.
Professor Chen.
For your presentation, here I have some questions for you. The first one is that given that you think that the before lactic acid bacteria seems like a very powerful feed. Okay, so I just wonder, are there any other similar products that use this bacteria in the agricultural farming? Okay, I don't know if you have ever done the survey for the fish feeds on the market. Okay, and the second is that this question is similar to Dr. Fan mentioned. Have you done any experiments to demonstrate the differences of the fish growth? Fish growth of the two groups, like the one fed with the before latest egg barrier, and the other group is none. Okay, without it. So I just wonder the effectiveness of the before lactic acid bacteria. Is that just such effective, just like you mentioned? You need to show me the evidence. Okay. And the third question is that, in this forum, Ocean Challenge Forum, we will choose the best one proposal, okay? And the price is $100,000, right? Okay, so if you win this prize, I don't know, how can you demonstrate this method? Because if you win this prize, you need to demonstrate this model. Okay, so could you just specify how you do this, how you to make this true? To cultivate the bacteria and then to feed the fish, and the fish really grows as you expect. And also the fish farmers accept this product. Thank you.
Professor Zhang.
Okay, my question is quite simple. Is this idea from where? It's very promising, and a very, very good opportunity to be successful. I'm just wondering, you just add where the original from, the concept, okay, especially the lattice acid, okay, and maybe you can just offer some kind of references. Where did you get ideas, and what's your kind of add something or creative thinking about the reference, and that's your original idea for whole this proposal. Okay.
Okay, it's C. Now you have 30 seconds before you answer the questions. Time is up. Please answer the questions.
So first, the problem with the experiment. Sorry, no, we did not do it ourselves, but Fisheries Research Institute, they have done it, and there's multiple scholarly articles online that prove the concept of this lactic acid bacteria having a good effect on fish. So, sorry, yeah, is it specific? Yes, it has been tested on only a few groups of fish, but it has a proof of concept that it can work on multiple species, and it has been tested on Taiwan fish anyway. So if we're just focusing on Taiwan, then it should be effective, even if it's not working on every single species in the entire world, right? Okay, so the third one is, the next question is it under experiment? Yes, it's under experiment by the Fisheries Research Institute. We haven't really done anything ourselves. So we're not really making it, okay. We're just making it for the field trips. We're not selling it. We're just trying to promote it. So the problem with the license, I mean, we're not publicly promoting it. Like, we're not publicly selling it, sorry. Yeah, so I don't think there should be a problem with the license. And solution. Okay, yeah, so there are a lot of solutions to fish farming practices. Like you mentioned, the water filtering system, but Taiwan, most of its fish farming is open sea fishing. So if you try to reuse the water, it's really hard to do that because it's in the ocean itself. So you can't really recycle the water. You can't like encircle the entire farm and then recycle all that water. It's very difficult and not feasible. Yeah.
Okay, so the question about whether the fish farmers actually accept this concept. So you're right. This is a very powerful product. It's a very powerful concept. And yes, you're really correct about that. So we don't really see a reason why they wouldn't take this deal, as in fish is a really big part of the economy. We're an island country. Fish is a big part of the diet. It's just a really big part of the economy overall. So then if this thing will help your product so much more and give you so much more money, we don't really see why they wouldn't accept it. Yeah. What else I have? Oh, and as you just mentioned already, the research is from the Fisheries Research Institute.
So how we found the idea and why we chose it? Basically, after a lot of research, we found it online and we thought it was like a very convincing and strong idea. So we decided to go with it and we put more research into it and found all this information. Yeah.
Okay, sorry. I just want to one last answer. Yes, there are, probiotics are not new to the world, right? But they're not very specific to fish. They're not tailored for fish, right? So this specific bacteria produces the right probiotic for the fish that doesn't you don't need to add additives to the yogurt to mix into the fish feed. So it just overall it maintains its like healthy image. Yeah. So yeah. Thank you.
All right. Thank you once again to ITSE. Thank you. Okay, very soon we have come to the last team from the teen category. All right. 那很快的，我们已经来到了这个青少年组的最后一组的简报了。And we'd like to welcome the people from the Plastic Chaser from the Morrison Academy, 高雄。OK， 那接下来呢，我们要请到的是这个来自于高雄马里逊美国学校塑化猎人队。OK，and they are going to present their Pure Ocean Project。要跟我们分享的是他们的纯粹海洋计划。All right, come to the stage. Yes.
This is not the next slide. Yeah.
All right, the stage is yours, Plastic Chaser.
Good afternoon, distinguished judges and honored guests. I'm Mike, and I'm the leader of my team, the Plastic Chasers. It is my great privilege to present to you our proposal, Pure Oceans, for the 2023 Ocean Challenge. As an environmentally conscious student, I'm deeply committed to making a positive impact on ocean protection. Through this proposal, our team is dedicated to tackling plastic pollution and contribute to protecting and ensuring the sustainable use of oceans.
I'm Yuki. We love spending time outdoors and exploring nature. One sunny afternoon, we decided to take a walk along the beach at the Tainan Gold Coast. The sand was warm beneath our feet, and the waves lapped gently at the shore. As we were walking along the beach, Mike stepped on something hard and sharp. He looked down and saw that it was a piece of plastic, partially buried in the sand. Mike was shocked and saddened by the sight of the plastic. He knew that plastic pollution was a big problem, but he had never seen it up close like this before. Jaden, Daniel, and Emily were equally concerned. After doing some research on ocean plastic pollution, we learned about the problem of microplastics. Microplastics are pieces of plastics that are broken down into smaller pieces that are smaller than 5 millimeters. These microplastics are too small to see with the naked eye, but they are present in large quantities in our oceans and can have serious consequences on marine life. We were shocked to learn that microplastics can be ingested by marine animals, causing them to suffer from health problems and even death. Microplastics that are small enough can get into our bodies and cause cancer or growth inhibition. We knew that we had to do something to raise awareness about the issue.
Okay, so my name is Daniel, and it is hard to raise awareness about microplastics because it is too small to see with our eyes. Now, there are different tools to detect microplastics. The laboratory methods, such as the FTIR, Raman spectroscopy, and SEM, can identify the type of microplastics, but they are expensive and take lots of time. And the traditional way of detecting microplastics using fluorescence involves staining a plastic with dye, then filtering it. However, this process takes a lot of time and has multiple steps. Some researchers have tried to make it more convenient by using mobile phone setups, but the process still takes time. Microfluidic chips are an emerging new technology. These devices are really small. They have channels to start a reaction with only a small amount of fluid. And they are better than traditional methods because they need less fluid, can give results faster, and are more sensitive. The microfluidic devices are already used in different applications such as medical diagnosis, environmental monitoring, and chemical analysis. In marine science, microfluidic devices can identify microplastics in one step. In our project Pure Ocean, we're using a microfluidic system to simplify the step of microplastic detection. We made our chip with 3D printing, PDMS molding, and plasma surface treatments. After some trial and error, we discovered the most economical way to create a PDMS detection chip. We presented how to make a microfluidic chip at the Conference on Ocean Governance 2023 last week. And today, we're presenting how to put the chip into practical usage. With computer vision, we have created a content screening station that can automatically and accurately identify the presence of microplastic samples. We plan to develop 2 AI algorithms in the coming future to improve its accuracy. With the help of these algorithms, we can differentiate between the different types of plastics based on their RGB spectrum.
So this is our prototype of the microplastic detection station. As you can see, the system is set up with 2 microfluidic chips. The one on the left is the reaction chip for the now red staining, and the lit up chip in the middle is the observation window for a computer vision capture. We coded an AI image program for image analysis and connected it to the system using a web-based style. After the program runs, our data is stored automatically. This system provides a continuous detection for identifying microplastics. which is essential for understanding the extent of plastic pollution in our oceans. In the next section, Jaden will give you a brief about our team.
I'm Jaden, part of a team that consists of one manager, Mike, and 4 team members, Yuki, Daniel, Emily, and me. We all have a specific role in the project. Mike oversees the overall project progression. Daniel does the software scripting and debugging. Yuki conducts the environmental sampling. Emily coordinates with external faculties, and I manage our budget.
So our plan is to install equipment at 3 checkpoints along the Gaopingxi, covering the upper, middle, and lower regions, as it is a vital public water source. Monitoring the changes in microplastic levels is crucial to evaluating the potential effect of microplastic pollution on our daily lives. We aim to collect data 4 times over a period of 1 month and subject to approval from relevant government departments.
Our project will be divided into the next several phases. For the first 2 months, we'll be working on setting up tools and software settings. Next month, we'll be working on environmental sampling, followed by 1 last month of data analysis. Throughout the project, we will keep our budget in mind and allocate our resources effectively. We will allocate most of our funds towards purchasing essential materials needed for building the testing station. While we are committed to ensuring that our budget is well funded, we also recognize the importance of collaboration and seeking support from others. We plan to plan a schedule and allocate our resources effectively and establish a timeline and identify any obstacles that may arise later. While we work together and leverage each other's strengths, we believe that we can successfully complete this project. Collaboration with established organizations is essential for our mission to protect the ocean. We recognize that it is a complex issue and we cannot do it alone. We plan to seek relevant NGOs and participate in their events and share our proposal and gain valuable insights from their expertise. Through these collaborations, we hope to build a strong network with like-minded individuals working towards a common goal of preserving our oceans for future generations.
Our microfluidic chip is a game changer in the fight against microplastic pollution. It is a cost-effective and efficient tool that can detect even the smallest of concentrations of microplastics in water sources. This allows us to quickly identify and quantify the extent of microplastic pollution in our oceans and waterways, and take targeted actions to address the problem before it causes irreparable harm to our planet's ecosystem. Moreover, by raising awareness about the issue of microplastic pollution, we hope to inspire individuals, businesses, and governments to take action to protecting our oceans. We can reduce the use of single-use plastics, as well as promote beach cleanups and responsible waste management practices. We believe that everyone has a role to play in preserving our planet for future generations, and our microfluidic chip proposal is just one small part of a larger effort to protecting our environment. We are deeply committed to this cause, and we believe that with your support, we can continue to make a real difference in the fight against microplastic pollution. Thank you for your time and attention. I'm deeply grateful for this opportunity and eager to contribute to a brighter future for a pure ocean. Thank you.
Thank you so much to Plastic Chaser. And now we go to the questions. Dr. Fan.
The presentation looks very interesting and show your technology. Okay, my question is, you mentioned you did a poster. It's low cost. So how much is the cost? And did you compare to other methods to show it's low cost? Then also you say, you mentioned there are several society foundation you would like to work with. And you have one team member working on public relationship. So did you contact them already? And what's their willingness to work with you? Okay. And actually, before your presentation, there are several presentations working on plastics. What did you learn from those presentations? And which one is the most helpful for you? Thank you.
Thanks for your presentation. I do feel your team like a real company because I saw the picture that you separate everyone to the different, like the director to be responsible for the different part. So I have the three questions I want to ask you. The first question is because you try to answer the question about the microplastic and how which size of the microplastic do you want to detect? Because actually for the different material or different machine, they actually decide to detect the different size of the microplastic. And how about your design? How about your product? And the second question is, we can see the picture that you just say that you do some experiment, right? So can you share some of your result for us? So how much water you filter and how many microplastic you detect? What is the density for your experiment and what did you find? Because I think it will be very interesting if your product can really work. And the final thing is I want to, because for your product, you just try to detect the density and the number of the microplastic. However, as we know, so although they are the small particle, but they may be not microplastic. So how did you deal with this kind of the problem? Thank you.
Professor Liu.
Because I also do research on the identification of the microplastic, and I just wonder what kind of how many type of plastic that you can identify, because the commercial one, the one that I use, it come up with a database with more than, I guess, 500 type of plastic spectrum. So how many type of plastic that you can identify? That's the first question. And then the same as Professor Ko, that how small is your sample? That what is the smallest sample that you can identify? Because, for example, mine can be very small. So in my laboratory, you are not allowed to call or sneeze, because once you do that, you're gonna blow the sample away. They're very, very tiny. And how small is your sample? And then, do you ever compare your result with commercial laboratories to see how accurate it is? Okay.
Professor Chen.
Thank you for your presentation. Here I have some question for your team. The first one is that it seems to me this project is all around making is making a chip, right? And this chip is to be used to detect microplastic in the ocean. So my question is that, is your team going to make this chip, or you buy it from the market? Because I don't know what's the chip. Yeah, I don't know how can this chip can detect microplastic. You need to tell me. You buy it or you make it by your own self. And if you make it by your own self, what would be the material? And this material is able to detect microplastic. Okay, down to the. My question is down to the point of your presentation. And the second is that how you think your product or this chip can do better in detecting microplastic and correctly than the existing product. Okay, thank you.
Professor Zhang.
Okay, two questions. The first one, so you do make the equipment just as the photo, yeah, already, right? Okay, and also you have sampling at that kind of a schedule for the first month, second month, and you have finished the sampling and also the data analysis. If you have done this, please share a little bit about the data, the analysis, okay? And what's your future plan? Because you are talking about the ocean, the scale is bigger than just the river. Okay, so that's the questions for you. Okay, thank you.
Now you have 30 seconds before you answer the questions. Time's up. Please answer the questions. 5 minutes.
So to answer.
Yeah, I think it's on. You probably just have to wait for 3 seconds.
So to answer Professor Fan's questions, our microplastic screening station costs around 10,000 new Taiwan dollars compared to other methods, which are far more expensive. That can go up to 10 to 20 times the price of our station.
Also to address the first questions, you asked whether
Yeah, just try again. Yes.
Whether we've reached out to various NGOs already. During our last conference, I brought up the fact that I've already reached out to various NGOs located in Tainan and Kaohsiung. But however, our ultimate goal for our project is to work with you. And for that, we hope to collaborate with you guys.
So, Professor Ko's questions, what were the sizes we want to detect? So, because of our microfluidic chip can vary in size, we can change it in the 3D modeling program, and we can detect as small as around 50 microns, which is the size our microscope can see. And we can change our channels on the microfluidic chip to fit the size we want to detect. So we took, your second question was how much microplastic we detected, right? So we took a sample from a beach in Tainan, and we just looked through it and we filtered all the organic materials out that were microplastics using another microfluidic chip, and we were able to get a few bits of microplastics. Yeah. And to answer Professor Liu's questions, how many types of plastics can we identify? So our microfluidic chip currently can only identify plastic and whether it's there or not. We're still working on an AI program that can detect what type of plastics by their colors appearing on the image. And how small is our sample? We can answer, it was answered in the last question. We can detect to 50 micrometers. Yeah. And we compared it to other labs. Like, so our chip is not as accurate, but it's more based on a cost-effective and efficient way, because we try to raise awareness about this issue, and detecting more accurately wouldn't help that much. This one. So to answer Professor Chen's questions. All of our equipment is homemade, and we made this chip using PDMS. It's a kind of polymer that is that has certain properties that like are good for our purpose. What's this? So our project is better for our purpose of raising awareness because it's cost effective and efficient, and it can bring results really quickly.
Time is up. Thank you once again to the plastic chasers. Thank you so much. Yes, Yuki, you're the one who's doing the lion roar in the video, right? Yeah, you look very different on stage. A bit tense and stressed. Okay. You want to do the lion roar again on the stage? No. You want to do that?
No.
As an ending to day one? Sure. Okay, give it up for Yuki. Woo! Yeah. That's what we're talking about. Okay. Thank you very much. Thank you. Okay, everyone. Day one of Ocean Challenge 2023 has come to an end. We would like to thank all the teams from the professional category and the teen category for their very informative and also very creative presentations. And we also like to thank 5 of our judges for their feedback and questions. Please give our presenters and judges another big round of applause. 我们再次给我们今天所有的团队跟我们的评审一个掌声，谢谢。All right, it's a long day. I should just let everybody go. And before you go, please return your badges. Yeah, they want to collect your badge. And while you can turn your badge your way out, all right? And you can take a meal box. And if you have signed up for accommodation, please also don't forget to collect your room keys at the reception table, all right? 那我们今天第一天呢，就到这边告一段落。再次谢谢大家的参与哦。那请大家呢在离场的时候归还识别证要签退，那同时领取餐盒。那如果有申请住宿的这个团队成员的话呢，记得要在我们的报到处呢领取您的这个房间钥匙哦。All right, that's it for today. We'll see you tomorrow at 9:30 in the morning. See you tomorrow.